held this morning day 2 of the Ghana Space Conference Accra. We are very excited to be here, and very excited to have you as well. If you're excited as I am, please, a round of applause for yourself. A round of applause for yourself for making it for day 2. All right. So this conference, as I understand, is the first of its kind, and we are starting very wonderful conversations that will permeate every aspect of our space journey. We are still a long way to go, but I'm sure we'll get there someday. All right, and without taking too much of your time, just a few housekeeping announcements. If you need to use the washroom, please step out, take your left. I think there's a washroom there for both ladies and gentlemen. Step out left, one for both ladies and gentlemen. My name is Chief Cosmos. Cosmos is my name. In case you are wondering, if you are doubting, it's my name. It means the universe, as I know you know. So I'm the right person to host this event. We are exploring the cosmos. So if you need anything, wave at me. I'll be your MC. Final announcement. I like to say this, and people take it as a joke. So we hope there are no emergencies. If there are any emergencies, I see only one front, only one door open there, and there's one here. So you have only 2 emergency exits in case there's any emergency. The announcement is this: please give room for short people to go first. No, I'm serious. Don't laugh at this. Short people are endangered species, and they must be treated as priority at all times. So in case there is danger, please make room for short people to go out first. But having said that, I'm very excited to have you. We look forward to a fantastic day too. I would like to invite the Managing Director for Space House Africa, Mr. Kweku Soma, who is also the lead organizer for this conference. Please, a round of applause to give us a proper welcome. This man likes fans. If you don't keep him fans, you can. Let's do that. All right.
Morning, everyone. Welcome to day 2 of the conference. I won't spend too much time up here. I just wanted to make 2 announcements. One is that tomorrow are the technical visits to the Ghana Radio Astronomy Observatory and the Ghana Meteorological Agency. For that, we'll be leaving from here at 8 a.m. because the road to Kutunse is long and not very good. So we need to leave early. So if you're part of the technical visits, please be here by 8 a.m. tomorrow at Easter Hall. The second announcement is that in parallel to the panel discussions today, there will be training on the Digital Earth Africa platform and services, which will be taking place in the breakout rooms, room number NB11. If you're interested, you can go to the room already. Otherwise, please talk to Edward Boama, who is leading the training. It'll be going on all day long. So in case you're interested in learning more about Digital Earth Africa's platform and its services, there's a training happening in room NB11 all day today. Thank you.
One more time for Kweku. All right, thank you very much. All right, so those with the posters also, you need to see Albert. Albert is outside. He's waiting for you. Those with the posters, you need to go and see Albert outside with the poster, with your posters. So we want to zoom in to the serious matters. Enough of my jokes. We want to explore why we are here today, Ghana Space Conference. Now, I would like to invite first to give us some good remarks from the Africa Astronomy Society, Dr. Benedicta Wood. Dr. Benedicta Wood, please a round of applause for her as she comes to give us a presentation. I thought we would do another one until she gets here. Please, one more time. All right.
Good morning, everyone. My name is Benedicta Wood from the Ghana Space Science and Technology Institute, and I'm pleased to share with you some reflections on space science and education, and then how we can work hand in hand to harness the opportunities they gave us for sustainable development. So growing up, as far as I can remember, in class 4, our comprehension teacher used to give us poems. There were a series of them. And every morning, he will have us recite one of them. And one of them that caught my attention was on moon landing. And so, if I remember, it was on how the Americans had always wanted to land on the moon. And this happened on July 20th, 1969. And when they got there, they sent a message to the people on Earth that Tranquility Base here, the Eagle has landed. And then the men down on Earth in the control room replied them that, Roger, Tranquility, we copy you on the ground. We are breathing again. Thanks a lot. So this fascinated me. It gave me an interest as to why they went to the moon. What are they going to do there? I mean, these are the sort of things that I kept thinking about the whole time until I got to about JHS. And then I was told that, oh, these are not the sort of things you do in Ghana. So you have to maybe travel abroad. So I sort of nurtured this. And so space science has inspired generations, humanity across generations, and from our ancestors using it for navigation, for telling the time, seasons, and then all that to what we have now, launching satellites in space, and then probably thinking of space tourism. And so the sky has always been a classroom without walls for us to learn and use. Okay, so a lot has been said about the benefits of space science yesterday, but the most important thing is that it is not as abstract as we think, but it is really what we are. Space science is us, and the benefit is what we see every day around us. So I will have to skip this. So going back to my story, how does a child like me, that I was inspired at class 4, move from being just a child with those imaginations to being a space scientist? And so what has been the driving force is education. So education is really what served as a bridge between my curiosity and then the curiosity of a whole lot of people, and it bridges the gap between curiosity and innovations. I mean, bringing out a product that will solve our life problems. So in education, we learn about the knowledge itself, and then also we get skills to extract the knowledge, which will help us build products and services of value, and which will give us the benefits that we need in life. So in solving our problems, space science is not only about when we look out or when our satellites are looking at us, but they are really just about solving problems. And these solutions are closely linked to the SDGs, which are the goals that we are looking at to better our lives on Earth here. So we have quality education, and then we have gender equality, innovation, and infrastructure. All these are shrouded in the solutions that we get from space science. And this has also been spoken about in the past lecture. In Ghana, our space ecosystem is growing, ranging from the research institutions to the universities, the ministries and government agencies, and then most importantly, the private innovators. So to talk about a few, especially for education, UCC has always been there with the training of the GMET workers. So they have a course in meteorological science. And then we have All Nations launching our first satellite. We also have UG that started postgraduate PhD, and then also they do some courses in first degree. Then we come to KNUST that launched a postgraduate course in MPhil recently. Then we come to GSSTI. So if you were here yesterday during Prof. Hall's presentation, he mentioned that he has trained in the past 10 years about 100 people, postgraduate students in astronomy alone, and then a lot more in MPhils, and then PhDs. So our ecosystem is growing, and there are a whole lot of the private innovators helping shape our ecosystem as well. So another exciting feature of space science is the opportunity that it gives young people and our industries. So really right now the world is going towards data science. Is so much in high demand, and being in space science gives you the opportunity, especially for the young people, to have all these problem solving skills to better our place in the universe. And also there were a lot of space tech entrepreneurship and satellite development schemes which our young people can take up. And then there are applications in climate science, agriculture, and then communication. So space science gives, in fact, from the young people to the old people, everybody an opportunity to thrive. Of course, there are challenges in our ecosystem. So really, most of our issues has been with access to STEM education, and then the limited infrastructure and resources that comes with it, coupled with funding. Funding is the most important problem right now in our space ecosystem. And then we also have a limited skill force, and then the big elephant in the room, brain drain. And then we also have an issue with public's awareness towards space science. So in all this, how do we go forward from nurturing curiosity to building technologies that serve us? So you will realize that in our curriculum, after I think grade 6, you don't hear anything space science until probably you come to the university. That is when you start hearing them. So the way forward is to probably integrate the whole space science and technology into our curriculum system, and then most importantly, build partners abroad to hold our hands while we solve our problems. And then inclusivity, so not just bringing women, but everybody on board, wherever you are. If you have the talent to be nurtured, the curiosity, bringing everybody on board. I was just about concluding. So in conclusion, space science is really about the people and the skills which we get from education, and then the opportunities that these skills will give us. And the whole driving force is going to be education. And so I will want our panel discussion to be tailored around how we can really use education as a vehicle to move from curiosity to building solutions and products that help us. And looking at the skies, we see the stars that inspire us. But then what we need to do is to really think about how we can apply the knowledge to our problems here on earth. And with this, I'll call everyone on board to come so we make this happen. Thank you.
Please, some water for Dr. Benedicta Wood, please. We need to use education as a vehicle to drive it from just curiosity to providing solutions. Right, I like that one. So the next panel conversation will be on education. Yes. Next panel discussion will be on space science and education. So when we sit down to discuss that, I'm sure you address some of those issues, and then everybody will be involved. So without taking too much time again, I would like to invite our panelists for the next conversation from Ghana NRW University Alliance, Dr. Beatrice Asenso Banai. Please, a round of applause for her as she joins us. All right, easy. Let's embarrass her till she comes. Keep clapping, keep clapping, keep clapping. Right there. And Professor Marvin Hall from Dara, Professor Marvin Hall. We also have Professor Bismarck Mensah from University of Ghana. We have Dr. Martin Egbelewegbe from University of Ghana as well. And then we have Dr. Simon Sovi from EPA. Thank you very much. All right.
Test.
Hello.
Test. Hello.
All right, thank you very much. Thank you very much. Again, gentlemen, ladies, self-disclosure, I'm not a scientist, so have mercy on me. All right, but we are very excited to have you. I would like to start maybe from my very immediate right. You tell us your name, what you do in the space, regards to Ghana Space Conference, what do you do in the space with astronomy and exploration, and then we know where you are and then continue from there. All right.
My name is Simon Sovoin. I work with Environmental Protection Authority for the past 21 years, actually. I did my master's program in marine science and PhD in environmental science. And actually, it's through those program that I came across the space, the technology issue, like GIS and remote sensing to be specific. So I developed great interest in those tools, how they can be applied in environmental management. So I actually developed a lot of skills in that area, and I've since been working and have interest in that. Thank you.
Thank you. Please.
Same with me. Okay, thank you very much. My name is Martin Egbelewegbe. I'm at the physics department of the University of Ghana. And I should say that my association with astronomy and astrophysics is a bit peripheral because my training is actually as a condensed matter physicist. But I've been involved quite deeply in matters involving the development of astrophysics courses at the University of Ghana in my department. Also, at the nascent times of the formation of the African Astronomical Society, I believe that was in 2010. And then also when the Ghana Planetarium began, and in the early years, I was also quite involved in their activities. Since 2012, I've been teaching the one single course, which is rather unfortunate, at the department in astrophysics. And I say unfortunate because it would have been very useful if we had many more courses in physics and astronomy, in astronomy and astrophysics at the department, yes. But that is me.
Thank you very much. I am Bismarck Mensah, Professor Bismarck Mensah at the School of Engineering. I have PhD in polymer nanoscience and engineering. So I am basically a material scientist. Currently, we are developing a curriculum for aerospace engineering, and I am part of the team that is developing the course program. I'm interested in the, of course, aerospace and then space technology. Thank you.
Hi, I'm Professor Melvin Hoare from University of Leeds in the UK. So I'll keep this short because I think most of you saw my keynote yesterday. So I lead the Development in Africa with Radio Astronomy program, and we've been present in Ghana for 10 years already, training lots of young people in radio astronomy and the related skills and how that can be applied to the wider space sector. And been involved in the supervision of many Ghanaian masters and PhDs, so there are several of my sons and daughters, I guess, in the audience, including Benedicta, who gave such a great context for this session already.
Good morning, distinguished guests and my colleagues. My name is Beatrice Asensubane. I'm the head of the Ghana NRV University Alliance Office in Ghana. Ghana NRV is a consortium of 8 universities from the state of North Rhine-Westphalia in Germany. We aim to strengthen the academic ties between the universities in our alliance and then the universities in Ghana. We do this through joint research collaboration. We also support student internship, academic exchange programs, and many more. I started my basic education or my bachelor degree in University of Cape Coast. I studied biological science and I did my master's in public health. During the course of public health, I had a special interest in using GIS in mapping distribution of diseases. So I applied for a scholarship to study GIS as a short course to be able to map diseases. But fortunately, instead of a fellowship for the short course, I had a scholarship for master's program for GIS and Earth observation. So I challenged myself, and then I pursue a pure master, somebody with biological science background. I made a very great shift in pursuing my master's in Earth observation and GIS. Then I developed a special interest, not in public health again. My focus was shifted to climate change. So I applied GIS and Earth observation in mapping above ground carbon stock for climate change mitigation. And then I further my education by pursuing my PhD in the same area, Earth observation and GIS. After my PhD, I was also awarded a fellowship by the DAAD as a ClimApp Africa scientist. where I also undertook most of my activities in the University of Energy and Natural Resources in Ghana, and then also in Germany. So I was also a research fellow at the Technical University of Munich, where I was with the Department of Big Spatial Data, responsible for analyzing big data for everyday problems, for solving problems related to climate change and many others. After my postdoc, I was also recruited by the European Space Agency as EO Africa Research Fellow, as a research fellow at the European Space Agency, Frascati, where we also develop data-driven solutions, scalable, transferable, for solving the many problems that we face in Ghana, especially deforestation, land degradation, water pollution, food insecurity, and many others. I'm very delighted to be part of this panel to share my experience with you. Thank you.
Please, round of applause for all our panelists. Wow. Wow. Dr. Beatrice, when he said he started your basic education at the University of Cape Coast, then he said your first degree. I'm like, hey, first degree is a basic education now. but I like that. I like that. And fantastic, all that you've been doing so far. I'm going to start with you again. So you talk to us first, right? Based on where you sit and where you work, the alliances you work, what do you see as the main benefits for developing international research partnerships? What are the benefits for it, and what more can we do in that field as a nation?
Oh, okay, thank you very much. As the saying goes, if we want to go far, we need to go together.
Yes, it's okay. Just have to get it.
Go fast when you go alone. And when we partner, there is an opportunity for us to share resources, knowledge, and then also technology. And as I mentioned, we have partnership with all the universities in Ghana, and what we do is we pair the universities in our alliance with the relevant universities in Ghana. So not related to only space science, we focus on all programs from humanity to science. When our partners are interested in any research cooperation or any research project, we match them with potential partners from Ghana. They put their resources together, their expertise together, and then they apply for funding. That is one aspect of it. We also support the universities in Ghana in terms of technology transfer, in terms of excellence centers in Ghana. For example, one of the universities in our consortium, which is Bramville Technical University, we have partnership with Ho Technical University, and through the partnership, we have established Digital Fabrication Lab, which is for the engineers to be able to prototype, test, and then be able to develop solutions that is grounded in our local context. So we have a lot of benefit in partnership, and as I said, no matter how sharp your teeth are, you can never bite water. And water in this context means the complexity of the global, problems that we have, which cannot be navigated by only one person or only one institution or individual alone. We need collective effort to be able to navigate. So partnership is very good for academic promotion and also academic development. Thank you very much.
Thank you very much. Please, a round of applause for her. And I'm putting that one in my pocket. No matter how sharp your teeth are, you can't bite it to water. All right. So still on partnerships, right? I'll come to you, Dr. Simon. Right. You are with the EPA. What collaborations, what opportunities exist for collaboration between EPA and academia to promote research? innovation and capacity building. Since you are still on that conversation, you can speak to it.
Yeah, so there are a lot of opportunities that exist for collaboration with the EPA. You know, EPA as an institution which is mandated to regulate environmental management in Ghana or activities that impact on the environment. Beside the regulatory activities, we are also mandated to carry out research work. So for research, there's always opportunity for collaboration with other institutions, research institutions, academia, and the rest. So currently, we even have a number of collaboration with institutions. Recently, there was a publication where there was a lot of talk about mercury pollution and then other heavy metals in food and other stuff, which the whole nation was actually talking about. It was a collaboration between EPA and then POF and NGO. So it's not only governmental institutions, we even collaborate with NGOs and other that involved in yeah. And then we also have opportunity where you can actually come for internship. That is if there's this availability of space. The current problem we have is that we don't have enough space, office space. That's otherwise, those days we used to have students coming for internship to collaborate with EPA to see what EPA does, and then also to learn on a job and then apply some of this in their training activities. Yeah, so there's always an opportunity for collaboration. And then we also have what you call domain-specific knowledge. You know, if you collaborate with other people, you tend to, you know, like the space technology that we are talking about now. If you are trained in space technology only, you don't have background in, let's say, environmental science. You don't have background in hydrology. You don't have background in geology. You don't have background in agriculture and other fields. It is a bit difficult to be able to apply the knowledge you have in the space technology in those fields because the domain-specific knowledge is also required. So when you collaborate with other institutions or other people, you are able to bring your strength and this together to be able to do more.
All right, thank you very much. We all need to collaborate to do more. I'll come to you, Professor Bismarck. I'll start with you on this one. What has been some of the biggest challenges in generating interest in space science? What has been some of the biggest challenges? And then how can institutions or government respond to this? Yes, I am. Professor Bismarck.
Really? Okay. Please, the question again. I didn't hear.
Oh, sorry. All right. So I wrote them down. So I told you I'm not a scientist. So let's go back to it. So I was saying, what are some of the biggest challenges in generating interest in space science? And from where you sit, how do you think government and institutions can respond to this?
Hello, thank you. I think Madam Benedicta summarized everything. Currently, awareness is a problem, it's a challenge. Yes. Awareness is one of the serious issues we are having now. People think space science is about launching rockets. It's not like that. But actually, they don't know it is connected to agriculture, environment, and all that. Again, infrastructure, as she mentioned, funding, these are all challenges. So the government should, currently, I think we have already passed the bill for the space agency. When it is enrolled, I think the government should pump in money to support. And then I think women in space is also have a very low in that area. So we have to encourage and motivate women by giving scholarships. The STEM education system should empower ladies to. Again, I think talented youth, when they graduate from doing science or engineering or space-related course, we shouldn't allow them to leave the country for greener pastures. We have to give them incentives or help them to set up their own businesses, entrepreneur, where they can build basic things in research or things that they've done in their areas. So that is what I have. Thank you.
All right, thank you very much. So for you, funding and then deliberately encouraging and motivating people in that space with STEM towards the youth and also the girl child. I like that. Those are, at least we can start from those ones and see where we get in. And space conversation, space education is not just launching rockets. I used to think like that, but it's good you've educated me now. I'll come to you, Professor Martin, Dr. Martin. How can space science be made more accessible and relevant to communities outside academia? How can it be more accessible and relevant to communities? Yes.
Yeah, thank you for the question. It got me thinking a bit, but I would start off by suggesting that space science and thinking about astronomy, astrophysics is actually something that should be extremely basic because of the fascination. You know, it's one of the most immediate things a person would engage with growing up. I mean, obviously, and you would begin to wonder, what are these things that are out there in the night sky? And I suppose that because it percolates every aspect of our human lives, you know, in terms of being curious about things, that could be a starting point, you know, to break into people's imaginations by giving them an understanding of where we are at in terms of knowing about the cosmos and the universe. And in that sense, I would say that it's not something that can reside only in the halls of academia. I mean, it's something that is accessible to everybody. And I think that our work is then cut out for us as people with basic knowledge in any of the spheres of astronomy, astrophysics, the applications of SAME as we've seen in this conference so far. And I really think that in terms of making people aware, we could use the tools of media, film, you know, film. We could use things like literature. There's a classroom. There are outreach programs such as the existence of planetariums. You know, these are things that are very easy to employ, but they also are front-facing to the public outside academia, and therefore people can really engage and understand a bit more about space science and astronomy in general.
Thank you. I think that's a very good approach as well. One of my favorite TV shows was The Big Bang Theory. I don't know if you saw it, and they just playing and making jokes with astronomy and everything science, and it sort of made it a little relatable. I mean, on a regular day, it's flying over your head, but when they talk about it this way, you get it. So yes, using media, everyday language, and I'm hoping that people get it. That's the thing, a good approach. I'll come to you, Professor Hori. You tell us a story. What inspired the development of DARA? What inspired the development of DARA, and how has it impacted research in space science in Africa so far?
Can you repeat it?
Okay. What inspired the development of DARA, development in Africa with radio astronomy? What inspired its starting, and then what has been the impact so far? Can we? Yes.
So did you ask how it got started? Or?
Yes, I was asking what inspired.
What inspired it?
Yes.
Okay. Yeah, I mean, a mixture of things. You know, I was aware of, obviously we were involved in already thinking ahead to the square kilometre array, you know, the British researchers at the time, and South Africa had won the bid to host the square kilometre array together with other African partner countries like Ghana. And I think already we were, myself and a colleague went on a sort of fact-finding mission to South Africa to try and start to build collaborations, because we thought, well, you know, if we're thinking ahead, we need to, just for our own benefit to start with, you know, we'll need to build research collaborations with the South Africans. So we went there and found out that they were converting this dish in Ghana. And around about the same time, one of these emails that pops into your inbox came along that said, there is funding from the Royal Society for UK-Ghana collaboration. And I thought, well, that sounds pretty narrow. I know astronomy activity that is going on in Ghana. I think we could get some funding there. So the South Africans were, you know, concentrating on the infrastructure side, and it occurred to me that, you know, we want to very much make sure that the citizens of Ghana can benefit from this amazing opportunity. It's, you know, the Square Kilometre Array is the first, you know, world-class global science facility located on the African continent, and it's, you know, it's a real major deal in the world of astrophysics. Would address many fundamental problems, and so, you know, that got me thinking that we could actually, you know, do a small bit. But then things kind of snowballed by being in the right place at the right time. And at that time, we seemed to have an altruistic UK government, which was also starting to do this innovative thing of using its overseas aid budget, you know, in a non-traditional way to actually use it for scientific collaboration. And so that opened up the possibility to then scale up what we had started in Ghana to many other countries in Africa. And we've gone on from strength to strength in that regard. So the impact, I think I outlined, you know, in my address yesterday, in terms of the numbers. And the DARA project has been operating in Ghana for the longest, effectively, and it's already clear now that where we've been operating the longest, we can actually see, obviously, the biggest effect, which one would hope has happened. Our aim is to establish self-sustaining research groups and academic groups that can carry on the training, you know, once our funding finally ends. And at GSSTI, you know, there's a cohort of people there now who can really push on, run the observatory, and you know, start training the next generation themselves. We're starting to, you know, see a lot of progress in some of the other universities as well. I mean, I've known Martin a long time, and we've always chatted about UG doing astrophysics, but you know, we now have Tech and UCC also starting astronomy courses, and UCC was interesting because they've actually started with an astronomy 101 course, if you like. You know, it's not just for science students; it's for all students across the whole university, just to come and get a feel for what astronomy is. And you know, we've sent them an optical telescope so that their students can come and have a look at the night sky for the first time. And one should never underestimate, you know, looking at Saturn through a small telescope for the first time, and you just go, wow. You know, looking at things on a screen is one thing, but looking at it through a telescope is pretty crazy.
Oh, that's interesting. Does UCC still do that? The basic astronomy course, do they still do that? The basic astronomy course. You mentioned UCC has a basic astronomy course for everybody, not just those in.
Again, I'm not catching that, but I mean, yeah, so yeah, astronomy courses are developing across different universities here. So you know, before we used to come and train the basic astrophysics ourselves. We're no longer doing that because the universities are taking care of that for themselves.
You did mention that there was a basic astronomy course for all students in UCC, right? You don't have to be an astronomy student, but something basic, if I got it right.
Yeah.
So I was asking if it's something they still do.
Like a liberal arts course, yeah.
Sorry?
Like a liberal arts thing, right? So it's open for anybody. So quite a lot of universities do this, across the world. So it just gets people in terms of interest.
Okay, just to get people's interest. Okay, I get that. I'm going to come back to you right now. I'll ask you the next question. What do you think? What are the key skills students should be developing today? You are with the GSSTI as well. You are with GSSTI as well, right? So I'm asking that, given satellite technologies and data science, given the advancements in satellite technology and data science now, what are the key skills students should be developing today? The key skills. Yes, that students should be developing today.
Yeah, I mean, this is something we emphasize a lot in the DARA project, because we take a lot of people in, a lot of people come out with the skills associated with radio astronomy. So then they gain a lot of computing skills in Linux and Python and data handling, also more increasingly now in the area of machine learning and AI. So these are sort of key skills that you need for all the downstream applications.
Machine learning, AI.
Mm-hmm.
Okay.
And then, the same technology on the antennas, the antennas themselves, the receivers and all the signal chain, extremely similar technology to what you need in your ground stations to communicate with your satellites. So, so both on the upstream and downstream side, there are a lot of transferable skills,
Okay.
which are absolutely key to this new technology.
All right. Thank you. Please, a round of applause for our panelists so far. Next 10 minutes, I'll try and wrap up, and then we'll take the microphone round. If you have any questions, you ask. But I've got to ask this set of questions also Professor Mensah, Professor Bismarck. What opportunities exist for engineering students in Ghana to contribute to space-related research?
Okay, there are a lot of opportunities. Students have the chance to collaborate with the international partners. Global Networks is there waiting for them. And then they are participating in space research will enable them to be able to do work in like developing miniature satellite, just as all nation students were able to do. Again, students will have the opportunity to research into materials, advanced material for space research related. And then, of course, they can also engage in entrepreneurship, where they can do their startup with some business development space related stuff. Thank you.
Right, thank you very much, please. Thank you very much. I want to come back to you again, Dr. Beatrice. It's always fascinating to hear from you, but how do we ensure inclusivity, especially gender, in the areas of gender, in socioeconomic status? How do we ensure that?
Okay, thank you very much. So as part of our mandate, we ensure that we have a certain number of representation, especially when it comes to grant funding. There should be a quota for women. Women must be on a panel. I'll also take ESA, for example. Even for the UO Africa research project, always they ensure that we have women on board. And then also for Ghana NRV University Alliance, application to DAAD and all the other third funding agencies, we ensure that we have a certain number of women. We also offer mentorship for women, give them the visibility. As I'm sitting here, is a kind of visibility for me. We need to, hear the voices of women and hear what they do, and that alone can also, inspire the other women there, because when they see their own taking the stage, they understand it, and then they know that, yeah, it is possible for me to also to get to this stage. So these are some of the things that we do, that is ensuring that we have women representation in projects, also in research, giving them the opportunity to lead, not just to be participants, but leading, being on board, membership and then also taking up leadership roles.
Right. Have you had to fight your way up as a woman? The dogma against you, and you had to fight your way up.
Please come again.
Have you had to fight your way up as a woman? This space, and
Yes.
with all this dogma against you sometimes.
Okay, I hardly had, discrimination as a woman or as a woman in exercising my role as a scientist, but I have a very good example of the point in my life where I felt I was discriminated as a woman. In fact, after my PhD and I did my postdoc in Germany, I decided to come to Ghana and then try to contribute my quota into the development of our country. So I applied to one of the universities here, name we heard because of,
For technical reasons.
Yes, yes. So I was shortlisted for interview. I went for the interview fully prepared, and I was able to show them how I was fit for the position. We had a great conversation, and everything indicated that, I had all it takes to take the position. Then after the interview, the chair of the panel asked me, so as a woman, finding yourself in a male-dominated field, why do you think you can be a lecturer or a research fellow in this area? Because this job, we make ourselves dirty. Can you go to the field? Then I explained to him how I actually was on the field during my training, and also even for my previous research, how I went to even the thick forest to take measurement of trees for carbon stock mapping. And yet he insisted that I should rather consider other fields where we don't make ourselves dirty, because that field, for them, they make themselves dirty, so that in his view, I wasn't suited for that kind of job. So I thought that I had been discriminated, but I moved on, and even that opened, a greater door for me. So this should also send a message to the women that irrespective of the challenges that you face, whether you are discriminated or not, believe in yourself, keep moving, and better opportunities will be there for you. Thank you.
Please, one by one for you on this one. They said don't make yourself dirty, eh? They said don't make yourself dirty. Dr. Martin, I'll come to you. Your experience as a lecturer, right? What are the most effective ways to spark and sustain students' interest in space science and physics?
Well, in general, by the time that the students sign up for the astrophysics class, they already have an interest. That's the one reason why they sign up for the class in the first place. But I think that the understanding of the possibilities, which are immense, is not apparent at the point at which they are signing up for such a class. And so I think that making it clearer what are the possibilities across all sorts of fields. I mean, our colleague here is from material science engineering, for example, and a person sitting in an astrophysics class may not immediately see the connection between material science and astrophysics, may not see the connection even between chemistry, and astrophysics, but these are all things that are intertwined. And I think that listening to what Melvin said about the course in Astronomy 101, which is available for all students, regardless of background, to participate in, is one way of ensuring that interest is generated across board, not just because somebody has been reading about it as like a pet peeve, a pet project in a personal thing in their use. So I guess that one way of increasing it is to make sure that courses that are university-required courses, like you have African Studies in the University of Ghana, could actually be set up that are doing things like basic astronomy. Yeah.
Like that. But quick question. Is there money in the field? Maybe that will motivate people. Let me just, I'm lying. It's a good question, right? It's a good question. Please. Is there money and how do people make the money? Maybe that's a good motivation.
Well, it's a good question, but I feel that for an endeavor such as science, which actually benefits a lot from what people would consider to be useless knowledge, it's not a very, very helpful question, because the output can be a lot, but the effect is not apparent. And throughout the history of science, this has been replicated. I mean, many of the technologies that are being used today are based on mathematics that may be like 200-300 years old. At the time that thing was being worked out, nobody had any idea of its possible use. So I think that kind of mindset should be what drives the endeavors in science generally. As for making money, if you make it big in football or music, there is no scientist that can approach your earnings. So I think that we should think about the excitement of the field and the contributions that can be made to knowledge, and that is where I would situate my answer.
But Bismarck, did you want to speak to that? Yeah, so we are saying that the curiosity, the excitement, the contribution you can make to science should be the driving force. That should be the motivation. And if the money comes, it's a bonus. They just add it to it. Right, I'm going to have the final take. Dr. Simon, you are with the EPA. What opportunities, in your view, right, how can space science education be better aligned with national environmental priorities and the needs of regulatory bodies like the EPA?
Yeah. So as I mentioned earlier on, there are several areas of application of this space technology. But sometimes, if you don't have the domain knowledge, you might not be able to apply even the skills you have in the space technology to solve a particular problem. So the best way to actually educate people is to bring people from beyond having the core space domain students. You bring people from other fields, fields like engineering, agriculture, hydrology, environmental science, and where you actually give them a tailor-made training where they can specifically apply these tools in their domain. So when it comes to somebody with, I like you citing hydrology a lot because that is my area of interest. So if you know how to apply this space technology in hydrology, you'll be able to quickly gather a lot of data, which either you can, when you use DTM, digital elevation or digital terrain model, where you also have two types, right? Digital surface model, digital elevation model. You can quickly use that information, assuming you are designing a drain or you are designing some area, urban planning, and you have this knowledge. You can quickly use this data, run a simulation. That if rainfall, this amount of rainfall in this area, which areas will be flooded? So that this can give you special distribution of the flood water, which can assist you in better planning for that kind of this in or maybe the area. So it is very important to, when you are educating people, we bring people from different domain, teach them how they can harness the potential of the space technology in their field of endeavor, so that they can better improve in whatever they are doing. Yeah.
All right. So that is one of the ways or the means that we can better align with government priorities, right? Bringing people from different domains and showing them the possibilities of what it is. We've been speaking for almost an hour. I think I have just about 5 minutes. if anybody from the audience, if you have a question, please shoot your hand up. The microphone will come around. Hey, can I do just 3 before I got beaten? So, yes, if you can take 3 questions. For starters. Please keep it short. Sorry, please keep it short. You mention your name, what you do in the space, and then if there's somebody the question is directed to, you could mention. But if not, I'll give it to another panelist. So please be up.
Okay, thank you, moderator. Labi is my name.
Sorry?
Labi.
Lamte. Yes.
Labi.
Labi. L-A-R-B-I. Mr. Labi. All right.
Well, I'm not into the space, but I'm into agribusiness.
Okay.
Yeah. Can I please ask the presenter a question? The presenter would hear a presentation before.
Dr. Wood, you are sitting here somewhere. They have brought you, you know. It's called stray bullet. Let's go. Yes. Yes. You say you have a question for us.
Yes, please. Thank you very much. You made two points. That is turning curiosity into innovation, and then integrating space science into school curriculum. I want to emphasize on integrating the space science into school curriculum. School curriculum keep changing, and I want to find out if the Ministry of Education accept your proposal. What measure will you put in place so that in case there's a change in the school curriculum, the space science will still remain in the school curriculum? Thank you very much.
All right, please. All right, so there are 2 hands more up there, but Dr. Wood will respond to this and we can quickly.
So, as Prof. Melvin said, so in UCC, they have Astronomy 101 as a university required course. And so it is in this vein that we can continue some of these things. And then as the curiosity gets nurtured and then they get educated and they have the requisite skills, we have all the institutions around to keep the young people in business, sort of.
Does that help, Dr. Labi? It helps, right? I'll give you doctor already because everybody here is a scientist. So carry on, go. All right. Next, yes, please tell us your name.
All right. I'm Christian Afrani.
Sorry?
Christian Afrani.
Christian?
Yes, please.
Afrani. Are you a Christian?
Yes, please.
Okay.
And I'm an aerospace engineering student at KNUST.
Right.
So I wanted to study aerospace specifically for the astronautics aspect of aerospace. But the sad thing was that when I went to the school, more emphasis was placed on the aeronautics. So I realized that then the space side of the things, I'll have to do them myself. So I started studying everything, gaining the skills myself. So when I gained enough dexterity, I tried to pass on those skills to some of my friends. And that led me into creating a space tech and skill training startup just a month ago that I teach kids block-based coding with a space team and also building ground stations.
Fantastic.
So I was very happy when one of our panelists spoke about entrepreneurship. So I wanted to know, are there opportunities specifically for funding for such startups or organizations with the mandate of trying to democratize space technology and space skills and train more people to gain the talent of space tech and space skills? Thank you.
Fantastic. Scientists like democratize. Wow. Sorry. So it's basically asking if there's funding available for people who want to go into space science, entrepreneurship, that kind of thing, to support, again, maybe not just entrepreneurship for profit, but for impact. So I don't know who answered that, but please hold it. Let's take another two more questions and we come back to that. Yes, there's a hand up there. Oh, there's one here, right.
Okay, my question is to the panelists.
So, Kwegu, wait a second. Kwegu, that gentleman's hand has been up for a while. After this, we go there. Okay. Right.
Okay. With what has been said, is Ghana going to be mainly involved in the data-driven section of the space exploration, or we have our own plans to travel to space and explore by ourselves with our own resources? And also with...
So you're basically asking, do you have any plans of going to space?
Yes.
Plans that we have, I can tell you for sure. But where we are is, I don't know. So EPA will come to you here. Say you are the only government institution here. So EPA will take that question. Please go.
Okay, and also with competitions being set up in high schools and other places like the Renewable Energy Challenge, is Ghana also having competitions in the space sector, to help students in high schools also gain their interest by starting up projects and stuff to help them out? Thank you.
All right, thank you. So let's do the gentleman at the back. Don't worry, I'll come to him. His hand has been up for a while, and then there are 3 questions.
Okay, thank you very much. I would like to say something a bit. I think the organizers of the program did well, but we know that space environment has a very broad entourage. Per my observation, I think this program is skewed to only astronomy. Sorry, I'm Dr. Samuel Abedu, a space physicist. And
Dr. what? Dr. Sam?
Dr. Samuel Abedu, a space physicist.
Space physicist,
yes.
Okay.
And,
with which institution?
From Brazil.
Brazil,
yeah.
Okay.
Brazilian Space Agency.
Okay.
As Dr. Martin was speaking, he mentioned that they have established or they have enacted some program, astronomy, right? Astronomy, if I'm right. So, astrophysics and astronomy.
Yes.
My question is, what are the plans for other physics environment, like the space physicists and the astrophysicists?
Okay.
Dr. Marvin, this question is for you.
This one is for Dr. Martin, direct.
Exactly.
Okay.
Thank you very much.
So this one is a straight bullet. It's a direct bullet. Okay. So there will be 3 questions. One was around funding for entrepreneurship. The next question was about what plans we have for going to space and where we are now. And I think there's a direct one to Dr. Martin that what plans we have for other fields apart from astrophysics. So I think we are going to delay a bit for coffee break. I'll come back to you. We are taking the first set of 3 questions. We respond to them and I'll come back to the next ones. So maybe we start with Dr. Martin first. We come to EPA and then I don't know who will speak to the question on entrepreneurship.
All right, thank you very much. And so the whole idea when we first laid out the course in astrophysics in level 400 was to actually slowly build up a whole range of courses that would cover the spaces that we are talking about. So essentially we would want to do something in astronomy, several modules in astronomy specifically. And then, even the whole idea of astrophysics has so many different aspects that we could have split into further courses. But that was at the undergraduate level. Our real plan was to create a PhD program in physics and astronomy with embedded astrophysics modules. And as you will be very well aware, the idea of doing a PhD in astrophysics means that you need a very, very, should I say, rare and sophisticated skill set, because you don't have a lot of people with a background in things like differential geometry, general relativity, or the whole range. If you want to do a program like that, you either have to collaborate very, very strongly with the institutions outside the country that have that level of skill, the people who can teach those courses, or you train them yourselves. Obviously, if we were to try to train the number of physicists needed to run such a program, it would take a long time. I think that the best way would be to collaborate, and I would mention, for example, Professor Hall here, who has been instrumental in helping us develop a number of these courses and create opportunities for some of our students to study in the various aspects of physics and astronomy and astrophysics outside the country. I believe that that is the way to go. In terms of paperwork, I mean, the courses are developed. We know the courses we want to teach. What is left is getting the skill set, the professors in those areas to engage, and then we can run those programs. Thank you.
All right, and then I'll come to EPA for your question. So does Ghana have any plans of going to space, and where are we now in that plan? Okay, EPA says it's not their domain. GSSTI, right? Do we have any plans of going to space, and where are we now?
Was the question about Ghanaians going to space?
Sorry?
Was the question about actual space exploration.
Yeah,
Was that
youngly, yes.
Yeah.
So basically, yes. Do you have any
And
plans for space
I
exploration?
mean, within the DARA program, we focus on the radio astronomy aspects because obviously we're trying to focus on preparing for the SKA. But in the wider program, then our space industry partners, so one of our long-standing supporters, who was previously the CEO of Goonhilly Earth Station back in the UK, Ian Jones, who spent time here in Ghana training people 6 or 7 years ago. So he certainly would has some interesting first-hand experience of how a dish like the 32 meter at Kutunze could be involved in deep space communication if you put the right receivers on it. So actually talking directly to probes. So they were recently involved in the Intuitive Machines landing on the moon, which I thought, I found out that Goonhilly were doing the ground segment, and so I tuned into this live landing, and you could see that it was supposed to have landed. They're waiting for the control signal, the signal to tell them that the spacecraft had successfully landed. It wasn't coming. You can see the fear on the faces in the control room. And of course, this was another mission where they were very nearly successful. One of the legs on the 3 legs of the spacecraft collapsed as they came in because they were coming in too fast and fell over. And so the antenna was pointing at the ground rather than pointing at the Earth, and therefore, even with the 30-meter dish at Goonhilly, they still couldn't pick up much of a signal. But they're involved in a lot of SATCOMs with the current lunar missions and Mars missions as well. And so it's another. If you've got a big dish and you've got the right connections, you can get involved in that side of space exploration.
All right. Thank you very much for that. I hope you got it, right? And after this session, most of the panelists will be around. We can engage them further one-on-one and ask more questions. But I'm going to take the last question, and then we'll respond to it. This one was on, is there funding for entrepreneurship in the space? Funding for people who also want to do things for impact and for profits. You want to speak to that? Yes, Dr. Beatrice want to speak to that? Yes.
Okay, thank you for your question. And as you know, entrepreneurship and then startup is top on the government agenda. And for that matter, the government of Ghana has this special cooperation with the GIZ. And from time to time, they have grants available for students or youth any youth who is interested in, setting up any venture. Apart from that, DAD, that is Deutsche Akademische Institut, German Academic Exchange, they have funding schemes for startups and many others. And your university, which is KNUST, has special partnership with Technical University of Munich, and they call it TUM Seed, which is also tailored for young, startups who are trying to innovate and then create something new. It is very useful that you contact or you link up with your university's innovation center, because I know KNUST, even the engineering department has innovation center, and then the business school also has business incubation center. Be part of them, and then from time to time, they get to know information about available grants and opportunity, and that will help you to be able to be part of it. And then also, DAD has a special program which is called Fallen Wall Lab, which is also, in fact, advertised annually, and young students are given the opportunity to pitch their projects, and they are supported when they are successful. And they also have the opportunity to travel to Germany and then, participate in the global competition where they are supported after a successful competition. So what I will advise you is try to stay in touch with your university's innovation labs, incubation centers. They have more information about available, and also on the internet, there are a lot of information on the internet. Maybe after here, I can share some links with you where you may find useful resources where you'll be able to get funding for startup or any other project that you want to embark on.
Thank you very much. That was very helpful. Please, round of applause for our panelists so far. I'm going to have to apologize to you. I'm unable to take any more questions for this session now. But we are still here. We haven't left yet. Most of our panelists are still going to be around. We need to zoom into the next panel conversation right now because one of our key panelists has to leave. And then after that, we do coffee break. And during coffee break, there will be more time for interactions and questions. But please don't run. I like the fact that we're engaging properly. It means more conversations are going to spark. So one more time, please, a round of applause for yourself. I'm going to ask the photographers, if one photographer can come around, please, let's take a picture of all the panelists together. Please, let's be on our feet. One of the photographers, please come take a picture. Dr. Benny, you don't get to go. I think you're part of the next panel. Dr. Beatrice, I said you're part of the next panel. So you don't get to go. Women in space and engagements. So the next conversation is women engagement in space. And again, we have Dr. Beatrice Asenso-Bane from Ghana NRW University Alliance. And we have Professor Amma Kluche from EPA. Please, a round of applause for her. Professor Amma Kluche from EPA. So, someone coming? Yes, please. Yes. No presentation. I just on a panel. Women in space engagements. Dr. Benedicta, now you are part of us again. Dr. Benedicta Wood. Right. So this is just women. Right. If I can have you sit in the middle, 1, 2, 3. Yes, thank you. This will be a short one. We'll be just focused mainly on. Yes, Dr. Banner, if I can have it a bit closer, yes, for the photographs. Unfortunately, I have to be the one to moderate. But I don't identify. I'm so a man. I don't identify as anything. I'm a man. I'm going to ask the women questions, please. Right, so I'll start with you, Dr. Banner. You are with us. You've told us your story, right? You've told us your story of how you started and the journey so far and everything. I want to ask you a very direct question. Were there any women in science? Were there any people who influenced your journey when you started? Was there anybody you looked up to?
Thank you very much. I would say that I'm a self-motivated person. From the scratch, I was determined to study science. And if you mention any other program to me, it was a no. So I developed that interest from the beginning, and I got myself prepared to pursue science. In fact, I had interest in pursuing medicine, but it got to a time that my interest shifted, and I studied public health. But I must say that somebody who also inspired me is sitting right beside me. That is Nana Amma.
Please, round of applause for Amma.
When I was at UCC, she was my TA. And then, in fact, any time that I saw her, in fact, that was a very big inspiration to me. And she was straight, I must say. And in fact, she helped us a lot. No dabbing. You need to work hard to make sure that you get the mark that you deserve. So that alone inspired me. And in fact, anytime that we have physics, then I have to be prepared before going to class, because you are going to meet Nanama, and she will ensure that you do your best, and in fact, she really inspired me, and I'm even short of words to describe how we try to, in fact, navigate our way during our school days. I would like to take this opportunity to say a very big thank you to
Oh, please.
and I'm not the only woman whom she inspired. She inspired many women out there. Anytime that we saw her, she was a great inspiration to us. No wonder that she's occupying this enviable position, and I hope that she will go further. Thank you.
Fantastic. Sometimes inspiration is sitting right next to you. And what's even more exciting is to have the person you have inspired now share a stage with you. I think that's a very good one. Professor Nama, I'll come to you, right? I'll come to you. Don't look too old to be inspiring people many years ago. I'm shocked. I mean, I don't think you're old, but you're inspiring people back in the days. But tell us your journey. What inspired you to pursue a career in space science?
Yeah, thank you and good morning, everyone. I'm happy that we have come this far in Ghana, where we recognize that there are women in the space, and indeed there are women to represent conversations on behalf of women upstage. I've said this before in a program, that there was once a meeting I attended on space science, and this was in Egypt or Ethiopia, one of the two countries in Africa. So in a room of 50 men or over 50 men, I was the only female in the room. So at a point I got up, I looked around, I'm like, I feel very frustrated. Are we saying the whole of Africa, I'm the only woman you can call to be part of this meeting in this continent and on space science? So that is when the men actually realized that, no, probably we have to do something else other than living things ordinarily in this space. So then it started work on women in space. But we have come a long way. Now we can count so many women in this space. Now on my journey. We will not finish the day if I have to go by my journey. Let me pick the most important one. So as she said, you need to motivate yourself. This is a space you actually don't see anybody to look up to. So at least she got me to look up to at some point, but I did not. Until I finished university, that is when I saw Professor Lute in person and greeted him. In fact, I ran towards him, so by the time I got him, I was panting. I said, young lady, take your time and talk. So since then, he motivated me in terms of encouraging me to keep on and on. But, you know, Martin said something here, Dr. Martin, before he on the panel. He said by the time a student sign up to his course, they already have an interest in it. So I already had an interest in physics before even meeting Professor Lute. But he coming to my life made me feel like I can't disappoint him, kind of, that drive. So it's like you are not doing something for yourself, but you are doing it for you to be appreciated or to thank somebody in a way. So all the time, I say I can't disappoint Professor Lute. That is one, and then also my parent. Physics came to me naturally. I used to ask a lot of questions. I still ask questions, by the way. Things I'm curious, so I want to understand why certain things happen in the way they do. Growing up in a village, we didn't have light, so we played a lot during moonlight when we have full moon. And on days where there are no full moon and there is dark, it's like kids can't play outside in the night. So I used to ask, why do we have some days where we can play out there and days that we cannot play? My parents, like so many questions. You see cars passing with lights, but we don't have light in the house. So sometimes we get a flash of light and then there's no more light again. And like, why can't we get those lights in the cars in the house? So then the questions keep coming and my parents will explain some, teachers will explain some, and they keep saying, when you go to school, do science. So do science on and on and on and on brought me to this far. But more importantly, I say hard work pays, but one need to be bold. There are some opportunities we got, I'm sure. Some of us here got, because we were bold. It's not enough to know, or it's not enough to want to work hard. You need to step up also to grab the opportunities that are available or that you can actually go for. Sometimes we are scared to move forward, but then you don't have to. Believe in yourself. Whoever is there was once like you. You could also get it. So this is the encouragement I give to the female character. You ask her a question. What has been her struggles, or if she has, So I just whispered to someone next to me that the female architecture itself is a struggle. We go through natural struggles. I mean, ordinarily, we are not at the same level with the men we sit in the classroom with. There are days that will be in our biological moment, and you are always free, moving about. We sit in the classroom, write exams with you in menstrual pains. We still are expected to pass the examination. We get pregnant, we go through childbirth, sitting in the same examination hall with the men. We are graded the same day, the same time, the same marking scheme. So that alone is a struggle, plus the other discriminations we face because of where we find ourselves in a men-dominated area. I became the head of physics department recently. So I left for EPA as the head of physics department. This is the first time in 75 years, University of Ghana is getting the head of physics who is a female.
75 years.
Yes.
Please, round of applause.
So getting there was a struggle. It's not that I don't qualify to be. There are levels you can reach to get to that level. But the men did not, even the women, did not understand how is it going to be like for us to be headed by a female. They've never experienced it before. So there are situations that we get to where we even women feel like, how will it be for a woman's leadership? So that kind of struggle is always there for us, the women. It may be subtle, but it's there. We feel it. And if you are not bold enough, you stay back and want to get into your shelf as a woman and want to take your gender role as a woman instead of being bold and facing the situations as they are. Thank you.
What was an inspirator, please? The female architecture itself is a struggle. It's discriminatory, but yet you have fought so hard to be here. On behalf of the men, we are sorry. All right, Dr. Wood, please let me hear yours. What has been your journey? What inspired this journey?
Thank you very much. As I said earlier on during the talk, so I had an inspiration from childhood, and I grew with it until, let me just jump to the university. In the university, I think we were about 70, and then 4 of us were women. Yeah, and then of the 4, I'm the only one here. So, yeah, so as Dr. Nanama, Prof. Nanama was saying, it really hasn't been easy. As she said, I was very pregnant when I was writing my PhD first year exam. And yeah, it was very tough. I can say it was very tough. But all I will say is that sometimes we should give the women a little rope. We should give the women a little rope. Not that we should really lower the bar, but help them. Yeah, that's all.
Thank you very much. And thank you very much. If any of you were to say anything to a younger lady, or to say no, if you say something to your younger self, 20 years ago, 25 years ago, when you started on this journey, what was the one thing you would tell that person that was not said to you before you started this journey? If you were to tell your younger self, right, 20 years ago, 25 years ago, when you started on this journey, what's the one thing you would have told yourself that no one told you before you even embarked on this journey?
So as Maria Curie said, nothing is really to be feared, but to be understood. So if I understood a lot of things earlier, I wouldn't have been bothered. So that's what I would tell my younger self and the younger women around here. You should try to understand things, and you will know how to navigate them better.
Oh, nothing is to be feared, but to be understood.
Yes.
You
And
understood.
now is the time to understand.
Wow. I like that. I'm going to take very simple ones, and then what I'll do is that I'll take maybe just 2 more questions or 3, only from the ladies in the room. But we try and give priority to that, and then we can try to wrap up this session. But I'll take yours, Professor Kluji. Yes, what's the one thing you have said to your younger self?
She has said it all. Probably the same thing. So if I knew the things I knew today, probably I'll be bolder, I'll be smarter, maybe better than today. So it's always important to learn and understand things. Yeah, but I will go on the path of be bold. I mean, speak out. Whatever it is, speak out.
Nobody will beat you. Nobody will kill you. Just speak out.
Nobody will kill you. Just speak out.
All right.
Yeah, that's it. Yeah.
Right, Dr. Wane, please.
So for me, I would have built my network before I need them. It gets to a point that there you need, in fact, support from other people. And you know, as a scientist, you tend to be a bit, we have a special term for it, anti-so. Yeah. So you concentrate more on books, and it gets to a time that you need support from your friends, your family, and other peers in terms of, let me take for example, as a woman, you have kids, you are going for a program, and other things. It gets to a time you may need family support, social support, people to support you to be able to do that. If you have this kind of strong social network, social support, you always have somebody to stand in for you when you have to, in fact, do other things aside your normal, family or your family life. So what I will also advise the younger generation is you try to combine everything, try to have a balanced life. Don't only concentrate on your books. When there is any program, participate. And then when you participate, don't just go. Let your voice be heard, be present. And you need to be also intentional about any decision that you are taking, and you will go far.
Thank you. Thank you. It said, build your network before you need them. Build your network before you need them. Be present, be intentional. And then when you get to the room, don't keep quiet. Talk as well. Let me just take a few questions, if any, yes. Now I'll come to you. You be my first. And then, okay, there are 2 women here. Maybe I'll give the last slot to a man so that we can quickly run this. Somebody can help me with the microphone. Yes. Yes. Let's start here. Go. Let's start here. A hand was up first, yes. Please tell us your name.
Hello, my name is Jennifer, and I have a background in space science and engineering. When I did my undergraduate degree, I was one of 3 women in the whole course, and before that, it was 7% women in the entire university. So my question is kind of two parts. How do you actually get men specifically, to listen to you? Because when I was in working groups, it was very difficult to get people to actually listen to what I was saying. Then we'd go round and round in circles, and eventually they'd realize that I was right. So how do you save the time and get people to listen to you? And the other part is, how do we get people to understand that the role of a woman has changed? So now women want the same roles as men in the industry. How do we get people to understand that women actually do want to do these things and then go on to support them in that? Thank you.
I like that. So, how do we get women, people to understand the role of women has changed? So as a political question, please, I'll take the one from the lady there, yes. I love your smile, by the way.
Thank you. My name is Sarah Abochi Masters. I'm involved in astronomy education and outreach. I personally know two of the amazing women on the panel, and I'm very impressed with the third, so it's a fantastic panel.
Thank you.
Congratulations for putting this on. So I meet young women who are studying science or physics, and they're sort of interested in going ahead into astronomy or space science. I wondered are there any kind of like mentoring schemes or, women in science groups that I think can help, mentor and encourage young women who are looking for that kind of thing in Ghana?
Right. Thank you very much. So 2 questions so far. 2 questions so far. One was on how do we get people to hear us? How do we get the men to hear us? And then how do we communicate that the role of men have changed, right? And there was a second question, she's saying, how the women group that mentor other young women to do that. I'll take a last one, and then we can wrap up. Oh, Abo. Yes. I'm taking only 3, sorry.
Hello?
Yes.
Thank you very much for the height that our mothers have gotten to, and we really appreciate their efforts and the vision and the picture that they are giving to our fellow women who are coming up within the space. In UCC, we did one-on-one courses or liberal courses, and I'm using myself as an example. So maybe a course like HIV, when we did it, there was nothing like continuous process with it. I know people did like Chinese, and they had the opportunity to use that as a leverage to do their masters in China and stuff like that. So this one-on-one thing that we are doing with the astronomy or this space thing I want to introduce as a liberal course or a compulsory course, how is the continuous education going to be like? I know one of the panelists made mention that there's going to be scholarship, but is it going to be skewed towards a science discipline, or are we going to integrate it? So how is it going to be like?
Yes, so there are 3 questions. So I'm sure you're going to share it. You probably take the last one. You take the last one, then there were 2 questions. One on mentorship and one how to tell.
Thank you.
Yes.
I want to take the first question on how to get the men to listen to us. How do you get to listen to the men? It's because you see that they always by their stand, or how do I say it? They are firm. So you need to be firm. You get a man to respect you when you are firm. You know that no matter how he turns you around or talk to you around, you are what it is. You are not a walkover or just anything. But it also starts by building yourself. So if a man sees that you are capable, there's no way a man will disrespect you. And it's in your workspace, it's in your homes, it's in the society, it's in the community. So we need to build ourselves and be there as a woman, independent woman as much as possible. The men may not like it. But then if you are an independent woman, some men are happy with that actually. Some don't. But really, you should be on your own, I might say. Yes, you need the men to support us. We need the men to support us. But then we are not talking about a support that's, I'm sure you understand. I mean, from the point from which you raised the question, you just need to be firm. build yourself, and be firm. I think these are the two key things you have to do. The other question is about getting everyone to know that the role of men or the role of women have changed. Nothing has changed here. We have our gendered roles, but that doesn't mean that we're doing the gender role of men. No. Women come to the table with different perspective. So in a normal setting, we follow the men trend because we normally, like in the space of decision making, the space of everything is about the men's style. But then you see a woman on the table and the conversation changes direction because we see things with different perspective. For example, in a home, a man's concern may be paying the bills. Your concern may be the children dressing well, appearing well in public, and those things. They are all roles we all need to play. It has not changed. Once in a while, a man may be concerned about the appearance of the children. Once in a while, you may be concerned about the bills in the house. They are normal, but we have our gendered role where you can breastfeed a child. A man cannot breastfeed a child. So nothing has changed. We just have to be in a realization of ourselves and the role we need to play in supporting our families and the society. It does not mean we should be here. You can't be here when you are supporting the family and society. You should be there. Probably the same level or height with the men, so you can provide a better support to family and the society. My point.
Thank you. That sounds very insightful. Please, a round of applause for Secretary. All right.
So on the women's group, I think what comes off head is African Geoscience women, and then there is, women in AfriGeos. Yes, they are doing a lot of work. And then also we have AFWA, Africa Network of Women in Astronomy. Yeah, so they are doing a lot of work around women issues.
So these are organizations that are open to anybody, any lady who can join?
Yes.
Right? Do you have links? Do you have
Women,
anything you can share?
Women.
Women, sorry. But are there links that women can access and join?
Yes.
Right. Okay. And I'm sure the incredible women here are available to have a conversation with you. If you want any of them to personally mentor them, when you go mention my name, tell them that they should mentor you and pick it from there. Dr. Mane will take the last one and then you can wrap up this.
Okay, so about the liberal courses and how you can advance it, I will use myself as an example. When I was in UCC, I did beginning German. And then it helped me when I applied for DAD scholarship to study my master's in public health. That gave me an opportunity or advantage over the other applicants. And it also helped me because as a scholarship holder, you have to also be able to have basic knowledge in the German language to be able to navigate yourself around the country. And it is a very good opportunity. So when it comes to space science too, we have many, many resources available. European Space Agency has portals where users can just get into the portal, and then, there are a lot of training materials. You can start learning how to process satellite imagery from start to finish by using the available materials. There are also webinars from time to time. Many resources are available for you to build your capacity if you want to advance the liberal program that you learned back in school. Apart from European Space Agency, like we have the Digital Earth Africa, they also have a lot of training materials to help you advance or upgrade your skills in Earth observation, data analysis, processing, and then many others. NASA is there. Many organizations in the space industry have resources, training materials, models available where you can utilize to be able to upgrade your skills and knowledge in Earth observation or space science. Thank you.
All right.
Just to add that, yes, we want to acknowledge that we have not done well in the liberal courses in the university. Probably just the University of Ghana has everyday physics as a liberal course for non-science students. So that is open for students to register and take the course, everyday physics. But that's only for the University of Ghana. Other universities, I don't know about KN University, but UCC doesn't seem to have a science liberal, like physics or space science related liberal course yet. So it's something we can be conscious of in deliberately introducing in the university curriculum. I'll try to start it
Right,
in
that's
the
all we need. The
universities.
try
Yeah.
is all you need.
Thank you.
We have a number of academians in the room and institutions. Please, let's take it up and let's help her as she tries to do that. Please, one more time, a round of applause for this incredible ladies. Photographer, if you can come and take one picture of our panelists standing up together. When we come back, we have a lot more to do. We have 2 more panel discussions, and then there's a one particularly for the youth. That panel discussion. I look forward to it very much. And so in the next 50 minutes, I think, we can go out for a coffee break. Please don't stay too long. We will need you to come back in time. So let's say we can all circle back here at 12 o'clock. All right, thank you very much. See you at 12. Please get settled in. Let's come forward a bit. Let's come out. Ushers, if you can get everybody outside to come in. We are about to zoom in to the next session. I promise the lunch will be very soon. Okay. We have only one panel discussion and 2 quick presentations, so we shall go for lunch. Those of us at the back, we can still move forward. There are more seats in front. I'd like to use the opportunity to also acknowledge our partners and sponsors for this event. Environmental Protection Authority Ghana, EPA, Ghana Space Science and Technology Institutes, Ghana Space Science and Technology Institutes. We have Ghana Meteorological Agency. We have the University of Ghana, the host, Ghana's Premier University. We have All Nations University. We have Agbedus Consorts, and most especially Space Hubs Africa. We thank our partners and sponsors for doing this with us. So all those outside, if you could kindly please come in. Let's settle down in front. Break time is over. Class begins in 3, in 2, in 1. All right, so we are here for the second session. We're going to continue from where we left off. So one woman, I think I've used it too much today. There's a banner. All right, but this time she's going to give us a presentation. So once again, help me welcome from the Ghana NRW University Alliance, Dr. Beatrice Asenso Bane. Please, a round of applause for her as she comes to the presentation. I promise the last one. I'm done with you. Please, round of applause for her.
Thank you for this opportunity.
So you can use this one.
It is an honor to stand here today, and just not as a researcher, but as a woman whose journey through space began in Ghana, and it continued to Europe, to Asia, and across the globe. I'm delighted to share my experience as a woman, and then other women who have also been inspirational to the many science community that we have. So, as I mentioned earlier, my journey started as a biological science student at the University of Cape Coast. And then from there, I pursue a master's in natural resources, that is Earth observation and GIS for natural resource application at the University of Twente in Netherlands. But before then, I did my master's in international public health in Germany. And I mentioned why I had a paradigm shift, because I wanted to map diseases with GIS and Earth observation technology. And for that matter, I did another master's in Earth observation and GIS at the University of Twente. From there, I continued my journey to China, where I did my PhD in GIS and cartography for climate change mitigation and adaptation. And after my PhD, I did not end there. I did my postdoc with the Technical University of Munich in Germany, where I also did my fieldwork at UNE, that is University of Energy and Natural Resources. The postdoc was focused on mapping forest cover and then also estimating climate change, documenting co-benefits and many others. After my postdoc, I had a fellowship for a research stay at the European Space Agency as EO Africa Research Fellow. So this is my academic journey, which spans from Africa, Europe, Asia, and then also I have also undertaken a lot of programs in the US. Please, next slide. Okay. So I'm happy to share with you women engagement in space, the trailblazers over the years. In 1963, there was a young lady from Russia who climbed into space, and she shattered the sky and then the glass ceiling. Her name was Valentina Tereshkova. She was the first woman to travel to space. She orbited the Earth about 48 times in a mission that was political because she had no formal training in piloting. She had a special interest in parachuting, and that led her, or that gave her the opportunity to be selected as a pilot to be flown into space. And she served as an inspiration to many women out there looking up to her to also take the lead into going to space. So she did not fly in vain. Her courage opened the hatch for others. And then follow Svelina, who is also the first woman to perform a spacewalk, and many others. Please go back. Yeah. No, to the previous slide. Yeah. So in 1992, a new kind of message emerged. That is when we had the first African-American woman also going into space. And she was a doctor, an engineer, and then also a dancer. She also gave hope to many African women that irrespective of your background, your race, your ethnic group, you have the possibility of doing whatever that you want to do. And in 2010, we had a history where 4 women flown into space at the same time. And this also sent a message that we as women, we are more capable of doing everything that we set our eyes on into doing. Okay, so these are stories of women who went into space. But I must tell you that space is not just up there. Earth is also a space. We are also already on space. But the sad thing is we do not hear the stories about women who are also making contribution in the space science on the planet Earth. So let me take, for example, we have Katherine Johnson, who is a mathematician, and her calculation ensured that the Apollo 11 landed safely. And then we have John Glenn, ensuring that the lady who is behind the calculation confirmed her flight before she took over. We have another woman who was also in the boardroom, ensuring that all the instrumentation and then the equipment and the control in the space industry or in the Apollo space flight was successful, who is also Joan Morgan and then engineer. On our own soil, we also have women who have been very instrumental in the space industry. We have Dr. Abimbola, who is the CEO of Nigerian Communication Satellite. These women are all contributing to the space science industry, but their achievements remain silent. And we have to project them, make their contribution visible, celebrate them. In Ghana, we have our own professor who is here with us, Professor Nanama, who is also making a contribution. She is a climate scientist, and she is also contributing to the IPCC authorship for publication. These women deserve a place in the space node. What can we do to ensure that we make them visible, we make their voice heard, we make their leadership known to others? We can start by ensuring that we write their names in our textbooks. In fact, I cherish history books and social studies books. Why? We get to know about our personalities and figures who are making significant contribution into the history, social science, and all the other humanity programs. But you take a science book, and then you come across Darwin, Einstein. They are unfamiliar to us. As Africa, we must try to develop our curriculum to suit our local context. We all agree that the contribution of Darwin, Einstein are very beautiful, and we are learning from them. But we should also make conscious efforts to ensure that personalities like this, we also capture their achievements in our science book as a great inspiration to our learners to be able to look up to them, to also reach where they have reached. So let's celebrate Professor Nanama, who is a Ghanaian and making a contribution to the history of Ghana. Please kindly change the slide for me. Okay, so this graph on the screen was a research which was conducted by UNESA, talking about women overall representation in the space sector. And I must tell you that only about 8 countries have women representation more than 50%. All the other countries are having representation below the byline. And this means that we are doing good or we are doing well, but we need to do better. Apart from that, you can see that when you take women representation, women, maybe, yeah. When you take women representation by region, here you can see that Africa is doing well.
Test.
Okay. You can see that Africa is doing well, but if you take in terms of leadership role and the management, I don't have that statistics here. I'm sad to tell you that Ghana has 0 representation in leadership and then management. That is, we have more room for improvement. Then we take women also representation by African, that is by region. That is the role that women play in space sector. And you take education outreach roles, you see greater proportion of women being represented in this area. But when you take roles like scientific or technical roles such as analyzing satellite data, designing mission, and many others, the representation of African women in this area is very low. That means we need to do more. We need to enhance our capacity building trainings. We need to have scholarships for our women to be able to advance themselves in these areas. As I mentioned before, we need to ensure that we give women the voice, the visibility that they need. We assign leadership roles to women, not only as administrators, but as head of institutions in Ghana. We need to be very intentional about these things, and then these will help us to be able to project our women higher. Please, next slide. So let me use myself as an example. As I mentioned before, Earth Observation Initiative by European Space Agency. This is an initiative which is jointly established by European Space Agency and then African Union Commission. And it is aimed at empowering Africans, not only women, to using Earth observation data to solve the pertinent problems that we have in Ghana: food insecurity, deforestation, water pollution, and many more. So every 2 years, they put up a call, and then they select candidates from Africa who are into Earth observation to apply to conduct a research at their facility. And as I mentioned, inclusion, women inclusion is top on their agenda. So they ensure that they include the women there. So even from the pictures that I'm showing, we have the new cohort. The new cohort, we have 2:2, so 50-50. And then ensuring that women representation and then men representation are equal. In my cohort, which just ended last month, the representation was 2:1, which is not bad. And then before my predecessors, the representation were 1:1. But above all, you can see that this is one of the meetings that we have. At ESA, we have small groups where we discuss research. And there are a lot of resources to support women to do their work. In fact, the EO Africa initiative should serve as a model for space, Ghana Space, because when you get to their facility, it is like a one-stop shop. We have all experts from different backgrounds. We have system engineers, we have remote sensing experts, all kinds of experts from all walks of life, which indicates that space science is for everybody. When you do your work or when you conduct your research and you are stuck at any point in time, we have experts available to support you, experts in every aspect, every field. And when the academicians cannot help you, they have industrial experts. They will quickly link you up with the expert behind all the tools, the resources. You have one-on-one discussion, dialogue with the experts behind those technologies. And when you are describing your problem to the expert who developed a tool, then that means your research is going to be successful. There is no way that any problem that you want to solve, you cannot navigate it. So I think this is a model that Ghana Space can also adopt, ensuring that their agency, when it is established fully as an agency, they ensure that they bring people from all walks or from all fields, from biology, physics, medicine, engineering, and many others, to ensure that they have an inclusive system in place. So here, the next slide. As I mentioned, the EO Africa initiative, they don't only grant fellowship to researchers to do their research work. They also have training materials where, irrespective of your background, if you are a biologist, you want to learn how you can use Earth observation applications in your work, there are always resources available to help you get started. They have materials from cloud monitoring, drought, food security, every field, every problem that you can think of in this world. They have learning materials on their platform, which is the EO Africa platform. And I think I encourage anyone who is interested in exploring the platform to channel on it. If you are interested in starting afresh, they have materials available to help you get started. So for the models, we have a cloud computing area where you can develop your code, you can develop your algorithms, and always the algorithms that we develop are scalable and transferable. If I develop algorithm for extracting water quality parameters, this algorithm, the algorithm that I have developed, should be able to apply in a different area. So if I apply the resources, the method in one region, I should be able to apply it, for instance, in Ghana. I should be also apply it to a study area in maybe Ivory Coast, in Egypt, or in any part of the world. So they ensure that this platform ensure that we avoid duplication, we share resources, we share data, and then also we share expertise. Please, the next slide. Okay, so since from yesterday up to now, illegal mining and its impact on water quality has been a topical issue at this conference. I would like to take the opportunity to show how we use the resources available in the EO Africa platform to analyze satellite data to extract useful information from the data available for evidence-based decision making. And as I mentioned, I chose this study area because, and I chose this case study because it is inclusive, ensuring that women lead the research. So I was the lead researcher on this project, and it is also collaborative. It brings all research from different fields, different institutions, different backgrounds, and also different expertise together to come up with evidence-based solution for Africa, which is suited for the Africa environment. So as you can see from the map, this is a map of Ghana. This is the map of Ghana. And as you can see, we have water bodies. In fact, sorry that the pictures of the water bodies were from Google Earth, which is not ethical. But you can see two different types of water bodies, one browning and then one also greening. You all know that water, if anything, should be blue. And if you see that water is browning or greening, then there is a matter of concern. You should be worried when you see water browning or greening. When there is browning, then it means turbidity levels of the water is high. And then when you see greening, then it must signal algal bloom, which is not good for the aquatic animals and then also for even for human consumption. So that means the water bodies in Ghana has to be assessed for quality in terms of domestic drinking, and then also for aquatic, and then plant and animal growth. So what we are seeing down there are the true image of the water bodies. We have two areas due to, let me press a point here. When we develop a model from satellite imagery, we need to validate it with institute data to ensure that the model that we have developed to assess anything, whether deforestation, water quality, or whatever, is a true picture of what is on the ground. And therefore, we need field data for validation. But in Ghana, it is necessary that we assess the quality of water given the impact of human activities such as uncontrolled mining and then unregulated use of fertilizer for farming. But then data on water quality is limited. The data is limited in terms of time, and then also is limited in terms of spatial extent. As you can see, we have more than 9 basins in Ghana, and for the 9 basins, we had data for only 4 of the basins for validation. And even the data available wasn't all year round. We had data available in January, February, then December and November. That means validation will be difficult. So as a case study, we concentrated on areas where we have enough data, and even the enough is not enough to develop a robust model, but we need to be able to do something with what we had. So we selected 2 areas for our case, which is Pra Basin, which is also well known for its water quality problem. And then we also chose Pond Dam, which is in the water. It is at the downstream of the water lake. And I don't know who can tell me which of the satellite imagery connects with the Pond Dam. Is there anyone here looking at the satellite imagery and then looking at the, do you all know, can you tell? Okay. Yeah, so here you can see that we have water lake, and this is downstream the water lake is the Pond Dam. And then where the other side, the map at the other side is the Pra Basin. Okay, so who can tell me which of the maps here correspond to Pond Dam and which will correspond to the river that we have over there? Which of the rivers? Okay, then I'll move on. So as you can see, the satellite imagery with the brown signal or the color code, very bright signal, is the Pra River. And as you know, this area is an area where the illegal mining activity is very, very intensive. And then when you take the other side, the river basin there, that is the Pond Dam, which is downstream the water lake. And this area too, agricultural practices is very, very, very rapid over there. And for that matter, you see that where we are having the release of fertilizers and other things, the water body is greening. And then where we have intensive illegal mining, it is browning. So why is the water bodies, which is being impacted by illegal mining, browning? Can anybody tell me from a simple, we don't need any expertise to be able to tell me. Can anybody tell me why the water bodies with illegal mining impact browning instead of greening? Because we have 2 different scenarios. We have a scenario where the river is browning, and then another scenario where the river is greening. Why do we have these differences? Yes? you help her? Maybe, yeah.
Sorry. Okay, please, can I try?
Yes.
Okay, so I know that illegal mining, they do a lot of alluvial mining. They agitate the water for panning to extract the gold and all that. So I am sure these activities increase the turbidity, introduce more sediment into the river, increase the turbidity, therefore browning the river. So this is the case of the browning. And in the case of the greening, I believe it's the introduction of, if it's not natural, then it's the introduction of chemicals such as cyanide into the water bodies, which cause the greening.
Excellent. Yeah. Yeah. So that is the case.
They said excellent. Let's clap for her. Right?
Yeah. So this must also tell us something that Earth observation problems are case specific and context specific. So you see, even in the same country, we have two water bodies with different problems. So that means when we want to adapt problems from overseas into our local context, we need to make sure that it's grounded. We need to calibrate it. We need to carry why we are seeing this. We don't have to use global data or global scenario to actually express how or solve our own problems. We need to develop Africa-led solutions to solve Africa-led problems. So let me show you how we use Earth observation technology to assess the water quality in these two regions. Please, the next slide. So before I move on, I've already narrated the situation, and then now the main problem in this two regions is data gap. So the research question for this study was that, can EO data enhance institute measures of water quality parameters? Because we know that we have water quality data available, but the data there are limited time. How can we use Earth observation data to fill in the gaps in terms of time? That is, if you want to have an overview of water quality continuously, that is not only for January or February or December, but for the entire year and also over a period of time. Can we do that from Earth observation data? And then also, can we ensure that we have data also covering the entire country, not only the selected few? So the questions set or developed for this research were based on that. And then another question that we sought to answer was that, can we infer from EO data the impact of human activities, and human activities in these cases, uncontrolled mining, and then also intensive agricultural practices, which also pollute our water body. So let's quickly move to the next slide and see how we harness or space science or Earth observation data in doing. Light moves around the water. They take signals of the water body. And as the signals are picked, we can actually extract the reflectances from the water bodies, and then we can, from the water body, from the signals, retrieve the water quality parameters from the signals that has been picked by the satellite imagery. I have to be very simple and avoid a lot of technical terms here. So for here, we actually tilted the European Space Agency Sentinel-2 data to the water bodies in Ghana, and then we have data covering the water bodies of interest. And you know, when you have the Sentinel-2 data, In fact, to be able to extract water quality parameters directly from satellite imagery, then we need to have optically, active satellites, which is the Sentinel-2, which is optical. And then when you apply atmospheric correction to a raw, which is the level 1 imagery, one of the outputs is the water quality parameters. So this is very simple to do. You get your Sentinel-2 level 1 data, then you apply the atmospheric correction, and then we have tools in the portal which can do that, but you can also, if you know how to code, you can also write your own code, then you'll be able to extract the water quality parameters from the raw Sentinel-2 data. So here, the water quality parameters that are sensitive or that can be retrieved from the Sentinel-2 data are the total suspended solids, which is an indication of water turbidity or the browning of the water that we saw. And then also we can extract CDOM, and then CDOM signals, dissolved solids material, such as if we have any traces of minerals or other things in the water bodies, we can use CDOM to be able to tell that, okay, the mining is having impact on the water quality. And apart from that, we can use NDCI, that is Normalized Different Chlorophyll Index. Those of you who did science in maths, back in school, when you take chlorophyll, chlorophyll is green, and then when you detect the chlorophyll content in the water body, then you can also detect that the quality of water, if it's low, if the chlorophyll content is low, then it means it signals algal blooming. So these are the processes that we use, apart from extracting or retrieving the water quality parameters directly from the Sentinel-2 imagery. We were able to use the process, that is the indices, band indices also for retrieving. And then after, I won't go into more details, to analyze the impact of the water, the human activities on the water quality. We also develop correlation between the indices that we determine, and then also we have indicators. As I said, illegal mining causes deforestation, you all know, and over time you have bare land. And then the bare land is filled with runoff water. So when you look on the satellite imagery, especially the very high satellite imagery, to detect the illegal mining areas, you will see that, for instance, you take time A, maybe you take January, and then you see vegetation on the satellite imagery, and then December you check, and then you see that it's bare land, and then you check again, you see that the bare land is filled with water, then it should send a signal that that area is being affected by mining. So this is one of the things that we use to identify illegal mining areas on the satellite imagery. Apart from that, we have indices, which is a bare soil indices, which also tells us that the area is affected with mining. Please let me run off quickly. Yes, so here we actually determine for the two areas. I hope you can see the rivers. You can see the layers of the rivers on the maps. So you can see that, in fact, our algorithm worked very well. It shows us that in the pond headwater, you see that the chlorophyll, which is the NDCI, was very high, whilst the turbidity was low for the pond dam. And then when you come to the Pearl River, you see that the turbidity index is high, and then the chlorophyll content is low. You can see from the maps that is shown on the screen. Please, next slide. And I said, when you develop a model, to know the performance of the model, you need to validate it with institute data. We validated our model, and then for the retrieval from the satellite imagery, which is done by application of C12CC processor, we had the performance as being 0.67, which is pretty good. And then for the NDTI, which is PON, it was also good, above 70%, and the same for the PRA area. So that means our model was good in this. Please, the slide here. Yeah, so as I said, we analyzed the trend for a long period. This was about 9-year period. So that means we've been able to fill the data gap. The data that we had for only 2 years with Earth observation technology, we were able to get data for a longer period of time. And then apart from that, you can see from here that apart from even the information that we wanted, the trend in water quality, we also got many information in drought. You see, when you see that chlorophyll content is high, then it means because we extracted only the water pixel, and we are seeing that for the pond area, the chlorophyll content is high. So it must tell you that there is an algal bloom. And then also, we are seeing that we have anomalies. Then anomalies must also tell you that there are episodal, like seasonal drought and many other things. So Earth observation or space science is a powerful way to solve African problems posed by Africans and also for Africa challenges. I won't go deep into the correlation analysis. Please let me conclude here. So what I would say is that space science is the silent engine behind at least 10 of the 17 sustainable development goals. And if we exclude women from this engine, then that means we will be driving with half of our power. Thank you.
Wow. Thank you very much. That was a very powerful lecture. Please, one more time for Dr. Beatrice Bane. If we exclude women in this journey, we will just driving only half of the capacity. Thank you very much. We are going to take another short presentation this time around from the NCA. The NCA National Communication Authority, Mr. Suleiman Salifu is here to give us a presentation. Please, a round of applause for him as he comes up stage.
Dr. Asensubane, that was a very powerful presentation, and I'm really impressed. I think I will contact you after my presentation for some discussions. I wish Prof. Danama Kluche was here. Last April 20th, the African Space Agency was inaugurated in Cairo. And before, I happened to represent NCA on the Regional African Satellite Communication Board. And we were at the inauguration where I met Dr. Brema Tando and Professor Yidana from the University of Ghana Computer Engineering Department for the first time. And before the inauguration, there was a presentation of a montage of the pioneering working group that actually put together the African space policy for it to take off. And interestingly, one person that stood up in that pioneering group during the presentation was Professor Nanama Brown Kluche. And although she is not here, I would like us to give her a round of applause for making Ghana and Africa proud. Not to bore you, I would like to go straight to my presentation on the topic Unlocking Ghana's Orbital Potential, Regulating for Sustainable Space Development. And mind you, NCA, that's the National Communications Authority, is the constitutional body that regulates everything electronic communications in the country. So from mobile telephony, radio broadcast to satellite, is the NCA that does the regulations. Distinguished guests, stakeholders, colleagues, friends, and all protocol duly observed. It is a privilege and duty to stand before you today at the Ghana Space Conference 2025, a landmark event that marks a significant step toward Ghana's space pursuit in technological advancement and sustainable digital growth. On behalf of the National Communication Authority, NCA, I wish to thank the Environmental Protection Agency, the Ghana Space Science Technology Institute, and all partnering institutions for this timely intervention initiative. This conference is not only a milestone, but a call to action for policymakers, scientists, regulators, and all innovators alike. Not to bore you, I would like to go straight to my presentation on the topic Unlocking Ghana's Orbital Potential, Regulating for Sustainable Space Development. And mind you, NCA, that's the National Communications Authority, is the constitutional body that regulates everything electronic communications in the country. So from mobile telephony, radio broadcast to satellite, is the NCA that does the regulations. Distinguished guests, stakeholders, colleagues, friends, and all protocol duly observed. It is a privilege and duty to stand before you today at the Ghana Space Conference 2025, a landmark event that marks a significant step toward Ghana's space pursuit in technological advancement and sustainable digital growth. On behalf of the National Communication Authority, NCA, I wish to thank the Environmental Protection Agency, the Ghana Space Science Technology Institute, and all partnering institutions for this timely intervention initiative. This conference is not only a milestone, but a call to action for policymakers, scientists, regulators, and all innovators alike. Space, a new frontier in national development. Ghana has shown a remarkable progress in space innovation. Orbital slots are not simply abstract coordinates in space. They are finite, high-level real estate. Ghana's geostationary orbital slot, registered with the International Telecommunication Union, presents a strategic opportunity to host communication satellites that can enhance broadband coverage, foster digital inclusion, and reduce dependency on foreign infrastructure. However, to secure and fully utilize this orbital asset, timely coordination and collaboration are essential. The NCA is committed to facilitating this process by providing the regulatory framework needed to enable access while maintaining compliance with international standards. The NCA's satellite licensing framework enabling growth and compliance. Prior to Ghana's National Space Policy 2024, the National Communication Authority had developed a satellite licensing framework to, one, guide the registration, authorization, and coordination of space and earth station operations within Ghana, enable the private sector and research institutions and international collaborators to access orbital and spectrum resources transparently and efficiently, ensure compliance with the ITU regulations, including coordination of satellite networks to avoid harmful interference, and lastly, to foster investor confidence through regulatory clarity and risk management. This framework is not merely a regulatory tool, it is an enabler of innovation, providing a structured pathway for local and international players to participate in Ghana's space economy. In line with the authority's mandate under the Section 64 of the Electronic Communications Act 2008, Act 775, which tasked the NCA with ensuring equitable and non-discriminatory access to the space segment for electronic communication services using satellite systems. The NCA has developed and published the Satellite Licensing Framework. This framework operationalizes Section 3R of the National Communications Authority Act 2008, Act 769, empowering the authority to issue guidelines and standards for licensing services, satellite services in Ghana. The framework outlines the categories of satellite services permitted, licensing procedures, applicable fees, and Ghana's obligations under international instruments, particularly the radio regulations of the International Telecommunication Union, ITU, in accordance with Article 18 of the Radio Regulations, ITUR, and the ITUR resolution 22 of the World Radio Conference 2019. All satellite communication services operating in Ghana require a prior authorization, including both space segment filing and coordination through ITU and Earth segment landing rights and user terminals. As the notifier administration on behalf of the Republic of Ghana, the NCA supports satellite operators in the coordination and submission of filings to ITU for both geostationary satellite orbit and non-geostationary satellite orbit systems. Additionally, the authority continues to grant satellite landing rights conditional upon ITU publication in the Radio Communication Bureau International Frequency Information Circular, which is called the BRIFIC, and subsequent registration of the Master International Frequency Register. As of 2025, the NCA has issued multiple landing right licenses to operators at Satlio, Internet of IoT Services, XL, AXT and Science, LLC, eSpace Incorporated, Cooper Systems, LLC, Ultrasat OneWeb, Ultrasat SA, and Space Exploration Technologies Corporation, and Avanti Communications Group, PLC, enabling a wide range of services from Internet of Things to satellite backhauling to broadband connectivity. In total, Ghana has granted 29 satellite-related licenses, 11 of which support last-mile connectivity, contributing to the surge in the user subscription from 2,666 before April 2024 to over 15,000 active subscribers today. The entry of large-scale non-geostationary satellite orbit systems into the Ghanaian market and the growing role of the space technology in connectivity and development underscores the need for a comprehensive and adaptive regulatory framework. The satellite licensing framework of 2024 ensures orderly growth, international coordination, and the sustainable use of Ghana's orbital and frequency resources in alignment with both national policy and the global best practices. The call for collaboration, our orbital future, is shared. To maximize Ghana's orbital slot and the potential of our satellite ambitions, collaboration is non-negotiable. The NCA invites research institutions and universities to engage in satellite development and frequency coordination, private sector partners and investors to participate in hosting communication payloads and space radio monitoring centers, and international stakeholders and satellite operators to collaborate with Ghana through commercial partnerships, hosted payload arrangements, or capacity sharing. Our role as the national spectrum regulator is to facilitate, not to inhibit progress, ensuring that Ghana's orbital resources serve both public and commercial interest. Looking ahead, regulations for sustainable space development. As we advance, our regulatory frameworks must stay adaptable, forward-looking, and grounded in scientific evidence. The NCA is committed to contributing meaningfully to the development of Ghana's space-enabling legislation. In doing so, we must, 1, strike a balance between innovation, security, and long-term sustainability. Honor Ghana's obligations under the ITU and other international agreements. And finally, align space-related activities with national priorities such as climate resilience, digital inclusion, and broader sustainable development goals. Let me conclude by reaffirming that space is no longer a distant aspiration. It is shared responsibility we must embrace today. To truly harness its potential for Ghana and the wider Africa continent, our efforts must be united, cutting across institutions, disciplines, and sectors. The National Communication Authority remains committed to working collaboratively with EPA, the Ghana Space Science Technological Institute, academia, innovators, and international partners to ensure that Ghana's space ambitions are anchored on sound policy, driven by innovation, and directed with clear purpose. Thank you, and may this conference ignite the partnerships and ideas that will shape Ghana's space legacy for generations to come. God bless you all.
Right. Space is no longer a far place. Please, a round of applause for Mr. Salifu Suleiman. Thank you so much, sir. All right, so good news and bad news. What do you want to hear first? Actually, it's bad news, depending on where you stand. So we may not be next panel discussion, the one on satellite connectivity, which also means that we get to go to lunch earlier. So I don't know where you stand and how this news sounds, but hopefully we will have some conversations around it, especially at lunch, and the further engagement we have. What we are going to do now, however, is to have a presentation on youth in space science and the engagement. We're going to hear from Albert Forsen from DARA, if he's here, and then after that we do lunch. Albert, is Albert here? Albert Forsen. Is Albert ready? Okay, he says he likes fans. Whilst he's coming, let's keep clapping until he gets here. Keep doing it, let's keep doing it. All right. So Albert is going to speak to us in the next 20 minutes on youth engagement in space science. Thank you.
Now, all the talk we've heard so far, we want to look for that 2.6 billion that the director of Ghana Space Science talked about. I want you and I to look for it wherever that 2.6 billion that is in that space industry. We want to look for it. So we wait for the slide, then we'll start that exercise. In this presentation, your mobile phones will be required, and specifically, your calculator will be required. Specifically, your notepad will be required, and your pen as well. We need to put down some figures and arrive at where that particular 2.6 billion is hidden. That is why the youth session is very critical and important for us. Okay, they are putting that up. So what I'll be doing, I will do the introduction. When the slide comes, we just jump into session. As I said already, my name is Albert Forsen. I am currently a PhD student at the University of Mauritius, and my specialization is in design and development of interferometer, basically how to build this telescope, do both astronomy and also do space. That is my specialization. And my affiliations also, as I said, University of Mauritius. I'm also a DARA scholar, developing in Africa with radio astronomy scholar, also associated with the Ghana Space Science Technological Institute. I'm currently the IAU National Astronomical Union National Outreach Education and Outreach Officer for Ghana, and working with an outreach organization called PRACSAC, promoting astronomy and space science in school through school visit and astronomy clubs. So that will be showing soon. Ready for me? Okay. So basically what we'll be talking about again is also on unearthing the potential, African potential in space industry. So just to note that with a continent with peculiar problems that we know, such as food security, climate issues, and also developmental issues, with that continent has a population of over 1.3 billion, how do we address such problems? How do we unlock the potential? We can unlock this potential addressing these critical issues that we know already by applying space technology. As the earlier speakers talk about and detail into some of these informations, using satellite technologies to talk about how our water bodies are being polluted, forests and coal, and the prominence of our current issue in the country is all about Galamsey, the water body, the forest cover, and so forth. How do we solve some of this problem? And also down to solving food security and climate issues. Again, we also know that Ghana, with a population about 30 million, about 57% are youth. Now, by the time we want to really look for the pioneers or people that can really bring this space industry up by developing applications, building the satellite technology and using applications. The youth, that is where the hidden potentials are. They have the energy to do all these things. Without the youth, we can't do anything. So we must look for the youth to be engaged and involved into these activities. Okay, so I think my slide number 3 will talk about now, after knowing all these demographics, we want to know again in Ghana what is actually the need of satellite data or these statistics, our application, we know. Especially we want to focus on the government of Ghana. What did they do in this area? But with the Ghana's space policy 2022, launched just 2024, a few months ago, they've identified some primary government institutions that uses satellite application daily. It becomes their daily food or daily breath before they'll be able to deliver a service to us. We know they use in these areas health, energy, disaster management, and so forth. So in that, the Ghana Space policy outlines some of these areas. Again, we also want to know these agencies. What are these agencies? We know some of them, their heads have been here already, talk about some of these areas, especially Meteorological Department or agency. They are one of them that give us a daily update. This update that they give us, the question is, where did they get the data from? Whilst Ghana do not have satellite out there. So they use this satellite application from a third party provide these services. For example, if you take NADMO, for example, if NADMO want to communicate to us, if there's any emergency, they have to apply or rely on some of these technologies. And we have other agencies that use security, marine services, if they want to, security, patrolling, and so forth. Some of these applications need satellite technology, or these institutions as well. Okay. Okay, yes, next slide. We are done with this. Next slide. Yes, okay, go back to, yes, next. Yes, so looking at this, where you and I are about to begin into a very quick exercise, I try to look for the actual expenditure of government of Ghana using satellite applications. But these informations are hard to get. They are not available just on the open net. But I tried to fish out some report by Space News. It's a Ministry of Fisheries and Aquaculture in 2016 signed MOU between 1 to 2 million for only 12 months. That is 1 year. If you can do me a favor, you can write that figure down, 1. And again, Ghana Cabinet approved 82 million digital migration contracts. So you can write that one also down if you care. Now, about the private companies that provide us a lot of services that we apply to, we don't know that. Individuals, we don't know that. I don't know how much satellite application for your extraterrestrial satellite TV stations application you use and I use. Those data is not available, right? That quantified data is not really available. And also, the actual of government of Ghana is not available. Next. Okay, so this, what do we know? I mentioned some of these already. These are the agencies, government agencies that uses this application, water resources and so forth. Next, Environmental Protection Agency and co. And forget you mean also Ghana Space Science Technological Institute has a remote sensing center that uses this data for their research each day. Next. So I want us to go into this exercise. So I look for these services by some of these satellite service providers, and they provide services if you are looking for satellite images or data for any research or to do any other work, we have super high resolution, very high, and I try to peg ourselves at only high resolution data. If you need that data just for one day, the minimum that you could get is for 5 kilometers square. That is $5, $5 for that size of data. If you are looking for a new data, the $5 data, meaning that data is already in the archive. The satellite has already fly over your location, and you are looking for that data after. But if you are looking for new data, you have to pay $8, and the minimum application or size you can get is 25 kilometers square. Now, if you are looking for a priority service, that comes as emergency. Just recently, we had an issue with a plane crash, and assuming our agencies are, I don't want to say it that way, but they want to track this immediately, they can just apply for these services and contact these service providers, and they will give them exact location where that satellite, where that incident happened, and they will track exactly. Meaning that we have to pay $12. Next slide. So this is where the calculation begins. So open your calculator now. So therefore, I take Ghana into consideration with our geographical coverage of 283,000 kilometers square, and I zoom down to Greater Accra. We all know that Greater Accra is flood-prone area. Every rainy season, Greater Accra is without flooding. So I want to zoom down to only Greater Accra. The coverage area is about 3,245 kilometers square. Therefore, if there is a flooding in Greater Accra, and the flooding happens, and we want to apply data for only Greater Accra, let's zoom down to only Greater Accra. Just multiply $5 by 3,245. If you do that, just write down. Again, let's assume that we need new data. This flooding persists 3 days, 1 week, and therefore we need new data to inform the security agencies or maybe NADMO and co. to prepare. We are aware that we have a very limited resources. So before these people move, they must be aware on situation on ground. Even fire services or other agencies, they must be very well informed before they move into the scene. So they don't also move into the situation. Therefore, we have to pay $8, and we have to multiply that by 3,245. You write that one also down. What about if it's an emergency that is happening and we needed that data now? We have to pay $12. What if this have to happen with the entire country? We need environmental monitoring, and it cannot just be only Greater Accra or Ashanti region. It has to be the entire country. If it is EPA, if it's even border monitoring control by the Air Force, we need to multiply that data by 283,533 kilometers square. So you multiply through 5 by that figure, 8 by that figure, and 12 by that figure. Again, that didn't end there. What if we are applying for these services for 1 year? How much do we pay? I want you to pin down, write that down as well. And if it's going for a period of 5 years, how much is Government of Ghana going to pay? Don't forget that maybe this data is applying to only one agency. And one thing I've also realized is that a data that maybe GSSTI will apply for and use, they use it because other services like Meteo or other services or institutions are not aware about the kind of data that GSSTI have paid for. So they use that one for themselves, and another agency, government agency, will buy or purchase for another vendor. Do you get it? Next slide. Yes. Is your answers equal to this? Just check. Are they correct? Very good. So you see how much we'll be paying, how much we are paying. Next slide. So take note of these figures and don't lose contact of it. Now, look at the African countries that launched satellite with a period of 3 years back. Kenya launched Taifa 1 2023. They spent 371,000 USD. I made a conversion in the Ghana cities. If you like, you do the rest yourself. Then Senegal also launched theirs, and they spent 1.2 million USD. Then Zambia launched theirs, and their range is between 300 to 600 million. Djibouti also launched, and they spent about 1 billion. It varies, it depends on the kind of satellite and application they want to apply. Now, I want you to fit those figures you've written down earlier on. The remark is yours. Just judge for yourself, conclude whether we need satellites or not, with the figures that we have to spend for 1 year per what these countries spend for launching their own satellite. The judgment is yours. Next. So, what can the youth do? The youth can do a lot. Applying space technology as a tool for sustainable development, and young innovators, the same can develop applications in agriculture and any other sector, data analytics and remote sensing application. Youth can do it. And we have proven, or we have a proven record that we have done it before. The first Ghana satellite launch in 2017 was by the youth. And the good news is that our brother is right here, was part of the team. So the youth can do it. Before Ghana 32-meter radio telescope was converted, a young scientist was sent from GSSTI to South Africa to learn a similar thing, the prototype type before the return for the conversion. So this shows that the youth can do that. Next. Okay, so fostering the space entrepreneurship and business incubation. Youth-led startups explore opportunities in satellite services, data analytics, space-based IoTs, and ground station services, creating jobs and attracting investment for Ghana's space satellite to be launched. So when these startups or these opportunities are created, individuals can start bringing up some of these ideas. Services can be provided. When we talk about in space technology, when we talk about astronomy, it is not only those who have specialized in astronomy that does astronomy. Also cleaners, because I've been to observatories where if cleaners are not part of that work, you will not be able to complete your research. I've been involved in a situation where I was building my antenna where I have to go through the struggle of welding. I've not been a welder before. I'm just electrical engineer. Welding have to be applied. Plumbing have to be applied. Electronics, there are a lot of fields that have to involve in this. Next. And then, where do we begin from? Because somebody will be asking, all this maybe because you are here, you are there. So where do we begin from? Yes, I think the STEM education from early schooling will be one of the places we should start from. So participation and competition and project is also another step for us. We join other innovation hubs and also internships, training, workshop, mentorship, and exposures, which I'll throw more light on that as well. Engage in national policy and curriculum development. We must also be involved in that space policy launch. Let's get it steady well and know what is there. So if you don't have a copy, you can see the writer of GSSTI have a copy and study that as well. We can also engage ourselves in self-learning and get there. Next. Key institutions that can lead you through some of this process are GSSTI. I'll throw more light on that. University of Ghana, also with their centers. We have GMED, we have All Nation, PRASAG, a group that is also doing that, can offer you training, internship, and collaboration projects that young entrepreneurs can also come on board. Next. So opportunities. How does this opportunity comes? So as I said, I'll throw light on those internship. So opportunities such as, I'm going to use myself now as an example. So somewhere from Regional Maritime University, where I graduated as a marine electrical electronics engineer, before going for my national service, I don't know where I'll be posted. I prepared myself in such a way that after school, I went for my marine course just to finish my national service and jump on board ship. So I did all my courses that I have to do and be a mariner. Then I end up at Ghana Space Science Technological Institute. During my national service, there was this 32-meter radio telescope being converted. Then I joined the team during the conversion. At that point, that is where my interest also developed. Because I'm an engineer and I like problem solving, I realized that I can also apply my engineering techniques or application over there, similar to what is happening there. No? So I ended up in having the opportunity when the DARA basic training came up. I joined the training. Through the DARA basic training completed after 1 year, then I had my opportunity to do my advanced DARA training at the University of Mauritius. At the University of Mauritius, I did my MPhil and currently on my PhD. These opportunities also come along with the travel exposure and other opportunities. But at this time, I want to also take this opportunity and say thank you, Melvin, for this opportunity created for Ghanaians and Africans. Next. So how did I utilize that opportunity? Knowing very well that we don't have a lot of expertise in that field, specifically, I decided or limited engineers in the field of antenna design. I took on the challenge where I was just handing over a palette of dish. I took through the design and the development of this 4-element interferometry from the scratch to the end. There you see what I was able to come out at the end of the program. So that is how I utilized that opportunity. Next. Yes, so there are other programs that you can also join, such as the undergraduate technical training. So where PRASAC also and the GSSTI create this opportunity with undergraduate students with physics background, engineering, and other background, go through this technical training, want to see how they can use this instrument set up by themselves, deduce data, analyze the data, and interpret the data through coding and other opportunities. So these are some of the opportunities that you can take on. Next. We have other programs such as school outreach and astronomy clubs in the basic schools, high schools as well, that these are also programs that you can also jump on through PRASAC and GSSTI. Next. We have teacher training program as well. So along the line, we have also identified that our teachers do not have the basic requisite or understanding to be able to handle some of this topic in the curricula. So we developed this training program where we involve them in the practical hands-on training so that they'll be able to catch up and be able to teach the student or our student the basic and have the very well-founded understanding before they move up. Next. Then these are also STEM outreach activities. We involve the student also in some of these activities so that at least somebody at the junior high knows what a satellite dish is, what is a main reflector, sub-reflector, what are the processes that the signal passes through satellite, and they did all these things themselves. Next. So, call to action, youth as pioneers of Ghanaian space future. So, we are saying that Ghanaian youth are encouraged to pursue STEM careers, participate in satellite projects, innovate with space technology, startups, and serve as ambassadors for the sustainable development shaping Ghana's emerging space industry. That is a call to action for all of us. Next. Then, what is our recommendation as youth? So we are saying that vision and institutional framework. One, we are recommending that, I want our staff to involve in this. We are recommending that the establishment of Ghana Space Agency is now, and to coordinate, develop, and also regulate funding to carry on these activities by the youth. We also recommend that we should embed Vision 2030 goal now. Ghana design, build, and launch its satellite now. Somebody may be asking, Vision 2030 is just about 4 years away. Yes, it is possible. 4 years we can do it because there is nothing new that Ghana is going to develop. Let's get that one fact. There's nothing new that have not been developed. Kenya has done it. Senegal has done it. Djibouti and other countries have done it already. Build, launch their own satellite. All that we need to do is to collaborate with them and get to the same goal. So Vision 2030 is possible. We can even do this before 2030 is up to. Next. We also recommend that a specialized roles should be assigned to tertiary institutions. If you take, for example, Tech, Tech should host the system development and overall satellite architecture. They should specialize in that area. We give like UG and also Regional Maritime University, we give them a special role of maybe a specific sensor development. If a Regional Maritime University is specialized in maritime studies, they should be specialized in designing sensors that will be able to look at our marine and detect so many things. All nations, if they should specialize in attitude determination and control system, they should specialize in that. Maybe our technical university can also specialize in power and energy substation and so forth. And if it's our other telecommunication universities, if it's communication and RF engineering, they should also specialize in this. At the end of the day, we bring all this together. Within that 3 or 4 years, we achieve the goal of designing, building, and launching our own satellite. Next. We also recommend that research centers we funded should be allocated. So if these institutions are hosting this program, there should be specific centers developed in those centers or those universities focus on space, technology, and application and the satellite design so that there will be accuracy in what they are doing as well. Next. Budget must also be allocated for them. Then we recommend again that the curriculum integration, we must now incorporate the application from the basic school. And this must carry on throughout to the tertiary first degree. And whenever we develop the talent at the first degree, we must not let them go. Keep them through master's program to PhD and beyond that. After that, by the time these people complete in 12 years, a child who begins space study in class 1 will now be doing his first degree in the same domain. And we keep them so focused in that domain. These are the recommendations that we are making and must be done now. Next. So private sector engagement. We recommend that private sector institution must be involved in this work, and specifically for long-term partnership. When the private sector is involved in the satellite design and the development with their funding support, they become a long-term partners of this satellite we are going to launch. Therefore, operation and everything, we give access to them how they use the data. Their government will not have to spend all the money or get all the money from its coffers. And also sustainability will be well established. Next. Okay, so just to say something is missing there. In conclusion, or my last word to say that if it is important, if it must be done, then it must be done now. Let us do it now, no delay, and we are asking our leaders that do this before you leave office. Therefore, Ghana will be proud of you. Thank you.
Right. Do this before you leave office so that Ghana will be proud of you. Thank you very much. Can you take some questions? 1 or 2 questions. Anybody well, something intriguing, something that intrigued your mind, want to ask, it's really, we can't step out. So yes, I'll take 2 questions. Maybe I see a hand up already. Anybody else? Anybody else with another hand up? Anybody else with a question? All right, so please tell us your name, what you do the space, and then.
Albert, thank you. Excellent presentation. My
Thank
name
you.
is Kobana. We've been talking anyway, you know. yeah, we were talking with Kuku through WhatsApp in the build-up to the program.
Oh.
We'll talk later.
Thank you.
On this presentation and on the goal 2030 launch a sovereign satellite for Ghana, I really admire that, and I think it's a really good, clear ambition. But the thing that bothers me is the security and how you protect your satellite from jamming, hacking, and spoofing. Because we cannot have a system where critical data is being procured from our own satellite, but some foreign agent can just jam it, and then we're at risk. And I see there an opportunity for our youth, because they're very skilled with tech. They can help you protect the satellite from jamming, hacking, and spoofing. So I think that there's an opportunity here for you, not just to have the institutions and the public sector behind you, but also bring the techie youth to help you create the security systems that your satellite will need. Thank you.
Thank you. So basically, yes, that is it, because there are so many things that we can do. We have the potentials beyond even the imagination of ourselves. But when the challenge is thrown to our doorsteps, we can do beyond that. And with that, we may even come out with any security, well, perfect, or the best security system that nobody has ever deployed before. But if the opportunity is not given to us, we don't know that we have those potentials. Thank you.
Right, there's another one here.
Good afternoon. My name is Kwame Amwa. I'm a student here at Legon reading computer science and mathematics. And I really appreciated the fact that you spoke of establishing courses from basic level up to university level and even beyond. Because I actually wanted to study something related to astronomy and astrophysics, but there's no program here like that. So my question is, how do we encourage youth like us to study it here? Because courses of such nature are prominent in the West and usually in Asia and all those other countries. So how do we nurture the interest here and keep the youth here so that they will continue to study the courses relating to space science and astronomy? Thank you.
Yeah, thank you. So to that, I may say that through DARA, the effort of DARA, GSSTI, programs in such as astronomy, astrophysics, and that has begun. In tech, they are currently students doing astronomy, radio astronomy, and UCC as well. I think there's UG as well. Yes, Dr. Provin and Dr. Benita Wood completed their PhD right here in astronomy, astrophysics. Yeah, so yes, there's some work towards that. The momentum is now building up, so we'll really get there. We'll get there. But with your communication with some of us, some of the seniors among us will guide you on what to do around some of this. Yep. And especially after this session, when the youth session comes on, there are some panels that are going to come and going to tell you their testimony, how they managed to reach that level. So there will be that real working group or engagement discussion. So you can ask them questions about how they reached there and if you want to read there as well. Thank you.
So, was that another hand? Yes, right.
Thank you. I'm Kwame. I'm with the private sector. And I really appreciate the elaborate discussion. But I appreciate the aspect of proposing certain area of specialization for the institutions. But I want to plead if there could be an extension, because I see that various speakers who also came on board were stressing the need for these webinars, training programs. If we could break the curriculum down such that you don't need to get to a PhD to make an impact in space. So let's break it down. Know the individual components that comes together to help achieve a certain goal. Then those skills can be used as models to train people. They know that I am specializing in just the RF aspect of satellites. Then my focus, my intention is to grow in that area, specialize in that area, gain the mastery, so that even if I don't have PhD, with my RF design models, I can make that impact in that area. We don't all have the same skills. We don't all have the same even financial capability to reach to that academic height. But the little we can do now will propel us to reach that height that we may also desire and the opportunities that may be available. So I appreciate it, but if there is any opportunity to break whatever system we have, whatever academic model we have, into different skill sets, then let's train people in these skill sets, then let them master it, then they can contribute to our space project. Thank you.
Thank you so much. In fact, just to add a word to what you said, one of the things that got me spy up when I was working as my internship during the conversion of 32 radio meter telescope was the engineers always come from South Africa. I don't know if any of the staff of GSSTI noticed that. They always come from South Africa and they'll have a working plan. Some of them just have a basic technical technicians. But because the consistency, they work in that area for a very long time, they are very much experienced. So they just have and bring the work plan. At the end of the day, when they give the work plan and the instruction to us, we're able to execute this and they'll be looking at us and we'll be doing all the work. Then I said, no, this cannot happen because we don't have the trained expertise in that area. So I took that challenge and said, no, I am going to specialize in that. I will no longer go to sea, but I'll stay in that and specialize in that. So yes, with some of this, to encourage them that we start very young, we can demarcate even from senior high schools that you are specialized in this area. By the time you go, you are in IRF, you just go to one of these institutions or tertiary institutions, continue your specialty in IRF, in tertiary institution and above. Then it's not be like you are trying to weigh your opportunities, whether you fit there or here. So yes, thank you.
Right, I'll take a last one. And then what we are probably going to do is, since it's still raining, we can't go out for lunch. So we're going to start the next session, the one on the youth engagement. So I wrap up everything. So I'll take a last one from Jennifer, right? Right.
Thank you. Just to add on to that, as there's a question for how we can involve the private sector and government in, I guess, promoting youth involvement, do you think there's any potential for apprenticeships in Ghana, especially at a university level? So that's for people who aren't necessarily academic, but who can get technical skills like you were mentioning, the welding and soldering, I'm guessing, any sort of electrical, more technical skills, to then still get involved in these space projects, but from not an academic background?
Yes, thank you. So specifically, yes. So all this boils down to policies. So once these policies are being made, we also love to be part of these policies making. That is why we are making this proposal, so we can make some of these suggestions. Fortunately, those of us have also traveled to see other people who are in other areas. Make some of these suggestions on board that the speciality should begin from here and here, and also in the curriculum, these recommendations to be taken up. So after lunch, I think we'll be diving into that, where we'll be writing specific suggestions, and we'll be presenting that to the GSSTI and also above for consideration.
I'll take the last one.
Okay. Thank you. Please, I am a volunteer with the Peace Corps. In Ghana, in Africa, many volunteers come from other countries to work in schools and teach. I think they would benefit enormously from coming to your teacher training. Please.
Thank you. So you either see me or you see Sarah right after here. She will give you specific. And there's one lady also behind you, any of them. So they'll give you specific instructions. Priscilla is you, so
Okay.
yeah, they'll give you
Priscilla.
specific instructions so where to join the teacher training program. I think this year soon, maybe in Kumasi or so. Yeah, hosted by Tech. Yeah. Thank you.
All right, thank you. Please, one more round of applause for Alberts. All right, so can you lead the next session? That one, youth in space engagement. Right now, because you can't go out for lunch, it's raining. So we can just wrap that up. Ernest, can I have Ernest?
Okay, NS, yeah, okay. Okay, so we have, if you joined this already, or we have some group works. Okay, please, those holding it, Terry, and those holding that.
Ernest, Terry.
Yes. Kindly find a place, and those in that group should look for you. Group 1.
Do you need a microphone?
Yeah, you are group 5. Okay. Please, if you join group 5, just walk to Terry. Terry, find a place so that they can join you there.
So let's stand.
They can be sitting because we are going to take about 10 minutes to do that.
So group 5 here, group 4 there, group 3, group 2, group 1. So please move to your group. Group 5, group 4 at the back, group 3, group 2,
Can you scroll
and
this
group
down?
1.
Please, if you haven't done yet, you can just find a group and join.
If you
now.
haven't, yes, you can join any group if you don't have a group. Group 5 here, group 4 at the back, group 3 here, group 2 at the back, and the group 1 here. Please let's find a group.
Yeah,
Can we just
Prosper,
start moving
Scroll
around?
this down for us.
All right. Please hold on. Hold on with that. There's a need for an introduction before this is done. So let me just do that quickly. Yes, the reason why the grouping is being done. I believe a lot of people do not know why the grouping is being done. Right. This forum is a short forum where we are introducing the Ghana Space Society. We believe in the unification of our voice as advocates of space science in Ghana. This is an initiative by all the partners, and we want the youth, advised by our experts here, to initiate the Ghana Space Society. And so the reason for the grouping is that we are going to different groups to discuss how the Ghana Space Society will be formed. I'll go through it shortly. It's on your screen. But then this will serve for the platform where we are going to have a very large number of space advocates in one society so that our activities can be well coordinated and can be well regulated. The reason for the groupings, when we go into the groups, we'll have one group discussing for the Ghana Space Society what could be the objectives and the goals. We also have another group discussing, Group B, discussing who could be the stakeholders, the key players, the partners, and the participants. And then Group C is going to discuss the society, the Ghana Space Society. What are the activities that you are proposing that by the formation of this can be done? And so the activities, the principle of operation. And then the Group D will propose the governance structure, leadership, and administration. Then Group E is going to discuss how we can promote the Ghana Space Society, the publicity and development and campaign. And so this is why we are going into groups. I know a lot of us have the technical know-how, and as youth, we go into the groups. You'll be able to support with your contributions. It may amaze you that we are saying so many things, space in Ghana, but we don't have a Ghana Space Society. And it's very important for the unification of our voice as advocates. And guess what? We want to initiate it now. So please help us by going to the groups, make your contributions. We'll have a leader who takes these things down. It will be reported. We'll have a framework document, and then the Ghana Space Society will be launched as a product from the Ghana Space Conference. Please, I hope you understand it now. All right, so please let's go to our groups. Let's identify
So
the groups.
are we joining the
and then we'll do
groups
that
based
now.
on preference? Boss, are we joining the groups based on preference or it's been selected already?
Yes. Based on preference.
So the
All right. So let me see what we have. All right, so group 5, if you want to contribute to how the Ghana Space Society, the promotion, publicity, and development campaign, please, we really need your contributions in group 5. Kindly come to him. I can see people already raising their hands for it. Group 4, defining the Ghana Space Society governance structure, leadership, and administration. You have expertise in that. You want to contribute to this. You are really needed in group 4. There she is. Group 2, Ghana Space Society, defining the stakeholders, key players, partners, participants. You are really needed in group 2. We are doing this quickly before lunch. Right. Group 1 is to define the objectives of the Ghana Space Society and the goals. They want to help us to do that. Group 3, yeah, I can read from afar. Defining the Ghana Space Society activities, participants, and principles of operation. Please, we will need you in group 3. And so please, let's kindly draw near to where our preference, the person of our preference is. Let's do this together for Ghana. And within 10 minutes, please, all contributions will be taken and reported. Thank you very much.
Okay, so we have a total of 10 minutes to have these conversations. I'm giving you 2 minutes to settle down. It's already 14 o'clock, that's 2 o'clock. So I'm giving you 2 minutes to settle down. 10 minutes. Please, this conversation is not just for the youth. Our experts in the house, reps from government, reps from institutions, please feel free to join any of the groups and contribute and make an impact. So group 5, group 4, where are you? Okay, group 3, where are you? Okay, group 2, where is group 2? Group 3 and 2, are you together? Where is group 2? And where is group 3? Right, so we have less than 5 minutes. Less than 5 minutes, so please be nearing wrapping up. And then remember to select somebody who can make a presentation. Thank you. Right, so time up, please. Time up. Time up. Can we? No extra time. Time up. So, can we all settle down and start looking here? My friend in black. Thank you. If you can sit down and look here. Yes. Okay. So I'm gonna hand you over to. Ernest. Ernest will now lead this session, and then you do the presentations. But lunch is ready. The rain is down. So the earlier we finish, the earlier we go and eat and take over and do the next thing. So Ernest, please, let's wrap up quickly.
All right, thank you. I'll go to each group in less than 2 minutes, please. In less than 2 minutes, kindly summarize what you have, and then we'll know.
All group reps should come forward.
Please, can we have all the reps come forward?
All the group reps. Group 1, Group 2, Group 3, Group 4. Rebecca, Jonas.
All right, all group leaders, please Group 4, kindly come. Group 2.
Group 5.
Group 2. Group 2.
Group 2.
Group 1. Group 1. Group leaders, please. Group leaders.
Group leaders. Group 1, Group 2, Group 3, Group 4. Group 1, Group 2, Group 3, Group 4.
So the one coming is coming to just give us a summary of the discussion, some of the points, in just 2 minutes. All right, group 5.
Okay, so good afternoon.
Please let's pay attention to group 5.
Good afternoon. So from what I heard from okay. So good afternoon once again. So we were asked to tackle tax 5 on the board. So my group members mentioned that yes, we should create social media platforms like LinkedIn.
Remind us of what we were working on.
Okay, so we were asked to defining GSS promotion, publicity, development, and campaign. So my group members came up with quite a number of ideas in which we can promote, campaign, and publicize GSS. So someone mentioned that we should create social media platforms like LinkedIn, Twitter, Instagram to help us promote GSS. And we should look out for events such as this one to outdoor GSS. And also we should have what we call the Ghana Space Society ambassadors who will be representative and tell people about what we do at GSS. And also we should have gatekeepers. We should liaise with gatekeepers. So gatekeepers are people of influence such as Professor Kluche who use their platforms to tell people about what we do at GSS. However, somebody asked a question which is very peculiar to what we are doing. He asked that why, how, and what are we doing as GSS? Because it is not fully defined. So we can't design a solution to what we don't really know why, how, and what we are doing. So he suggested that we should use the design thinking approach. And then somebody also mentioned we should align with already existing disciplines. So a lot of people are aware of space technology. However, they are not aware that space and GIS moves together, or climate change can be tackled with space technology. Thank you.
All right. Thank you. So the question asked will be answered by another group, right? So we should have gone that way. So group 1.
Group 1.
Group 1.
Our discussion was based on the goals, defining GSS objectives and goals. That was our topics. And we came out saying that for our objectives, we should inspire more youth to get on board, where we focus on, exposing SHS students to, space science, ideas that is not just about maybe going to doctorate or whatever, but we have space science as a way of, when they get to the university.
Please, the timer.
And we also discuss fostering research. So one of our objectives is to make researches about space, the space industry. And the other was on economic empowerment, where space technology is about, making the economy stable. So it's not just about maybe an individual kind of interest, but the economy at large. And innovation, where we bring on board new technologies, new ideas from various, space, agencies. And the last point that we tackled on under objectives was promoting STEM. Basically, we all know about STEM. The STEM are kind of idea. And under it, we have TVET curriculum where for the TVET Institute, you are supposed to, introduce to them space, curriculums where they'll be able to get themselves, familiar with. Okay, sure. And training teachers, establishing space clubs in various SHS and the university, and women empowerment, where for the sake of gender equality, we are supposed to get involved, females as well. And under the goals, we tackled on representing international bodies, international space agencies like NASA and the rest. And the last was advocating the reasonable use of, outer space, where we don't just use, okay.
Where we use the time. Okay. Next. Group two, please.
Hello. Okay, so we are group 2, and then our topic or activity was we should define the Ghana Space Society, their stakeholders, their key players, partners, participants, and etc. And our facilitator was Mr. Jonas. Yeah, he's right beside me. So we started listing some key stakeholders that we have here in Ghana. So we spoke of some NGOs, private institutions, civil society organizations, and also the government. So we also talked about the purpose of these key players, of these key stakeholders in the Ghana Space Society. So we said that they manage the affairs related to space and around space policy. We also said they promote space education and technology utilization. We also said that stakeholders with shared interests are supposed to come together so that we collaborate between space-related institutions. And we also made mention of GSST, that is
Ghana Space Society and Technology.
Yes, thank you. We also went on so we asked ourselves what are some institutions that comes to our mind in terms of space science, and we listed so many of them. So we said GMEDS, EPA, GSA, and we can't leave the government out. Yeah. We also spoke about some world or international space institutions. We talked about SpaceX, NASA, World Meteorological Organization, World Bank for funding, African Union, Blue Marble Space, when it comes to education and research. And our universities, we have All Nations, Ken University, University of Ghana. We also made mention of technical universities. Thank you.
All right, thank you. That was very good. Group 3.
Hello. Group 3 was focusing on the activities and principles of operation for the society. So our facilitator broke us into 3 groups to try and get everything a bit more organized. Our 3 groups were about the background, what the society would require, what the gaps are that we would address, and what we would predict for the future, so a kind of roadmap for where we wanted to go. So I'll hand over to group 1 first.
Yeah, so we are not going to reinvent the wheel here. GSSTI has already made great strides in the proliferation of space science in Ghana. So these particular tenets, that is harnessing, coordination, researching, commercialization, and exploring. These are 5 verbs on the GSSTI website. And we found these to be very useful as extracting them to be core tenets of the Ghana Space Society. We also established principles that the society should be founded on. So boldness, authenticity and consistency, reliability, and then policy definition. With regards to the policy definition, we hope that we just don't define policies, but we are able to put them into action, because such has been a problem in Ghana for a while. We also plan to go on with activities such as bridging the gap between space industry and space academia, giving outreach and awareness programs, collaboration with international organizations, and the establishment of a local data hub. Thank you.
Okay, thank you. We identified a few gaps that the Ghana Space Society will have to close. So first, access to information on satellite data, TLEs and stuff. Then there's the second one is a 3-in-1 problem, unfamiliarity with space science due to lack of proper integration mechanism in the educational system, which then leads to this stereotypical criticism of people who want to study space science. And then we have a financial constraint. In the term, most of the times people have to use their own funds to fund themselves in this factor.
I have 2 seconds, but subsystem design courses and imaging processing courses for older people.
Wow, that was a very good discussion. Group 4.
Okay, thank you. So we are group 4. And our topic is defining GSS governance structure, leadership and administration. So first, we spoke about reaching out to the whole public. So we don't want this to be only one-sided, for example, just those in the workforce or something like that, but we want to involve every single person. So those in the workforce, the youth, and we have children as well. So for our governance structure, we'll have like the circuit leadership, something like the main board, then we'll have subcommittees or we'll have wings. So as I said, we are involving the whole public. So perform an election from the membership we have. So when we perform an election, we'll have the president, the vice president, the secretary, financial secretary, organizers, and yes, and etc. And then we'll have, we also have under our administration a small secretariat, which will be in charge of the publicity and reaching out to the public. So when we're talking about membership, we're not talking about only Ghanaians here in Ghana. We're looking at domestic here, Ghanaians here, and then Ghanaians in the diaspora.
All right, so in addition to that, as a society, we have to have a constitution that is supposed to govern the whole society. So fortunately for us, we've gotten a lawyer who has volunteered to draft such constitution. So in that constitution, the rules of the various positions are going to be stated out and everyone is going to follow. And also we are going to have annual general meetings. And also, I think after every 2 years, we are going to have elections to re-elect new executives, right? Thank you.
Wow, thank you. Very fruitful discussions. Now, what is going to happen is that a Google Drive, a Google Form document will be created, and you see these themes on it. And each group will contribute to that document on a certain deadline. Then, we want it to be done by the youth and for the youth. Then, we are going to receive experts' advice, like our experienced lawyer here will now advise how it should be done. Please, I hope that's okay. And so the documents will primarily be created by the youth and for the youth. And they will receive advice from the experts. I hope that's okay. And what we are going to do is that each and every one who has contributed or a contributor, we will always have our names beneath the document that when the Ghana Space Society was formed some years ago, we were a part of that. I think that's a very good compensation. All right, so we want to take our first picture advocating for the Ghana Space Society before lunch. And so please, let's all come forward here. we'll take our first picture. And this picture will always be on our document. And so make sure your face is showing.
Right, I'm gonna call you in order. So the first person to come and do the presentation is Emmanuel Provin Ajri. Emmanuel Provin Ajri, are you here? Emmanuel, is that you? Oh, smile at me now. Emmanuel is smiling. Please, a round of applause for Emmanuel as he comes to do the first presentation. I check 1, 2, 1, 2. All right. Technical team, are you ready for him? His presentation. And let's put a timer there. 8 minutes. Technical.
So my time.
So we'll take it from their time. Track A. Track what? Let's track 2 oral A. Track 2 oral A. Shall we? Right. So time starts now.
Okay. Good evening. My name is Provin. I'm presenting on Spacebots, building Ghana's next generation of space innovators. This a small startup. We have started to help the young generation so that they can also be part of the space ecosystem. Okay, the next slide. I have 7 minutes. And then the next slide again, maybe I think that was fine. Okay, so yesterday we heard a lot about commercial space and what is in there, about 400 billion of revenue. But in Ghana, it's still something that is still in the formative stages. There's not much skills or young people who are ready to take up this challenge. And then also in Ghana, there's this thing that you always hear from people. It's like, oh, this innovation is being done in this country. The West people are doing this, the young people are doing that. But you don't see any commitment or kind of like investment, deliberate investment to change that narrative. It's just always in our mouths. We say this is happening here and all that, but deliberately how to start building stuff so that we can begin to change that narrative. That is actually not the case in Ghana. So the next slide, please. So we have seen this as a challenge where we want to inspire the next generation and train them to become space innovators so that it will not just be a word of mouth, just saying it with mouth. The Chinese have done this, Ukrainians have done this, Russians have done this. No, actually begin to take steps so that within the next couple of years, that will begin to bear fruit. So what we want to do is to train these young people in robotics, engineering design, and then applied space technologies so that this narrative can begin to change. Yes, the next slide, please. Yeah, so we have what we call the iStar Smart Kits, where we target young people and then we train them in Arduino, robotics, and Python programming and all the other codings so that by the time they get to a certain age, they already have this mindset of coding and using their hands to build stuff. So that is what we have been doing for some couple of months back now. And these are young kids that have put their hands inside all these electronic circuits and programming the LEDs, the sensors, and the motors, and putting together all the stuff that we see there. Yes, the next slide, please. And we also have some hands-on projects that actually build a lot of confidence, a lot of competencies among these kids. One of them is a light detection center where you wave your hand and then the light goes off or comes back on. So these are things that we build them, we help them to understand, not just putting things together or like giving them a code, okay, put this code there. No, I think do it step by step, and then we add complexities to it, and then you say, okay, now reapply it to this, so that they begin to get the concept themselves, and then they begin to understand troubleshooting themselves, so that if you write a code and you simulate it and the code is not working, our colleagues are here, we just smile at them, we just laugh, we say, okay, can you fix it? And they come and say, can't fix it. I say, okay, can you just check again what is there? Yeah, we're beginning to build this kind of consciousness in them so that they begin to identify how these things are being fixed, so that it's not just like giving them code and then saying, click the button here and all that. And then, yeah, these are just nice kids, just being happy that they've built their first smart traffic light. They build it themselves, they put the code themselves, and then we actually ask them to explain what they have done, not putting any words in their mouth so that they can actually own what they are doing. And then there's another group there that is building some smart waste management systems, bringing together actuators and motors to get these things done, and then program it. And then another, or the flagship one, is the obstacle avoiding robot, where they also learn how to understand the various components that go into building that robot, and then now programming the whole robot, and then keeping that information on that, you plug it out from the computer, and then it's still able to work. Okay, the next slide. Yeah, so the whole space ecosystem is a very big one. You talk about figures and people start shaking their heads, but we are just trying to build an ecosystem that links education to kind of enterprise, so that the young people begin to see that this whole space that you're talking about, this country have this and all that, they are just small snippets of things that people can put together, and they can still own or can still make a very meaningful impact on this within this space ecosystem. So transforming this early training in robotics and space technology into future-ready startups, where with time they begin to see certain applications that they can build themselves, things that they can do themselves. Yeah, that's what we are trying to do. Yes, the next slide, please. Yeah, so we're looking for collaboration to scale this up so that we can reach at least 1,000 kids within the next 3 years. We are not looking at fanciful numbers. No. We want people that actually understand what they are doing, and they can walk away from us and apply the knowledge to several fields that we have not even envisioned of. Yeah. Yep, thank you. That's all I have.
Okay. Can we take one question? Anybody with a question? 1, 2, going 3, going 2, going 1. You will release. Please, a round of applause for him. All right, so next person, please make sure you're also doing well in time as well. Dunamis, are you here? All right, please a round of applause for Dunamis Uzochukwu. Dunamis Uzochukwu. Traktu Urabi. Do you have it? Traktu Urabi. Please let's clap for the man. Are you a scientist? In between. I fine boy, they do science there. I don't see some before. It's not true, eh? He's not a fine boy. But we are more fine boys there. This is the one I've seen. Allow him. Let him take a shine. All right. Now we 8 minutes starts now.
Okay, thank you. It's too short. Greetings, everyone. As he has mentioned, my name is Dunamis Uzochukwu. Yes, I'm a Nigerian studying at Mauritius University. So I'm presenting on connecting the unconnected. Next slide. What's the root? Okay. So the hero of this whole story is something called the hybrid satellite terrestrial network. So now the problem. So for most of us here, making a phone call or texting someone on WhatsApp is something you do without even thinking about it. You just wake up, what, I forgot to text this guy. Just take it. Then text this and the message is sent in a matter of milliseconds. But this is not the case for a lot of places in this world. This is not the case for a lot of places in Ghana, also Nigeria. There are some rural areas that have very poor network connectivity. It's basically useless. It does not really exist over there. I don't know if you've traveled to any place like that. I've experienced it personally, and it's very, very, very annoying. So, yeah, that's it. So, next. So, the current network operation that we have is one where, let's say, you are called someone as in Medina, and you're in Kaswa. Your signal goes through, it hops through several cell towers, and then it gets to Medina. So now, imagine if Medina had no cell tower or no cell tower in range, how will your call get to that place? Next slide. So from the graph here, this illustrates the coverage, 4G coverage of Nigeria and Ghana. So you can see that the green bar is urban coverage. They are pretty well, they have good coverage. But then the rural areas only have 50% of this basic 4G coverage that we all enjoy today. Next slide, please. So now, my research. So, what if instead of looking for how we keep trying to put cell towers everywhere, let's use satellites. So, in my research, what we are doing is to see how satellites can transmit directly to your phone. So, how satellites can transmit directly to your phone, your regular mobile handset, without any modification. You don't need satellite antennas, just your mobile phone. And then we use certain parameters to measure the quality of this. That's the coverage, the link power budget, and then the selectivity. Next slide. So the software I'm using for this simulation is the main software is the AGI SDK, ANSYS Government Initiative System Toolkit. So first of all, I'm using Starlink as a case study because they are really well off, and I'm focusing on low Earth orbit satellites. So I'm using Starlink as a case study. So first of all, I get the satellite coordinates, which are known as TLE, two-line elements. So these two-line elements enable you to simulate the satellite's movement or the satellite's orbit relative to the Earth in real time. And then I get transmitter parameters, and then I input them into the software that can simulate the transmission of the signal the satellite down to Earth, and then the antenna parameters. Then the second thing is the simulation of the user. So what we are simulating here is the phone. So the parameters of a basic smartphone. I'm not using your phones. Basic smartphone. So the location. So I chose specific locations that I've investigated and discovered that these certain locations do not have good coverage. So I get those locations, put them into the simulation software, and then I attach the receiver parameters. And then there's a simulation of connectivity, which is also known as the link power project. So I can get certain figures to tell me that this signal is good, whether this signal is good or not. Next slide, please. So, starting off with the simulation SDK, this is what the software looks like. The software interface. When you begin to do more things, it gets much more complex. Next slide, please. Okay, so this somewhat scary looking diagram that you are seeing on the screen is the result of one of the simulations I've done. So this is a simulation of 93 satellites over one particular region that does not have cell coverage. So what you're looking at is a revisit diagram. So actually, Starlink has up to 11,000 satellites. I just use 93 satellites for the case so that I can impute data manually. So on this graph, you can see that if this pie chart was full, then you can see that this location would have 100% coverage. But right now, it has a little bit of gaps inside. The satellites will go and then they will revisit again. But the gaps are very tiny. So if I'm just increase this number from 93 to let's say 120, I believe that this area will get complete cell coverage. Next slide, please. Okay, so yes, this is a carrier to noise ratio graph. So this graph illustrates the main parameter for determining whether you're receiving a strong signal in your phone, yes, in your transmission. So this graph is a simulation of a 2-hour period of one of the locations receiving from the satellites all at once. This is a 2-hour period. And then the carrier to noise ratio is in decibel, it's a relative power measurement. So right here on the graph, the lowest cutoff point is 40 decibel. And the minimum receivable carrier to noise ratio for a good signal is 20 decibel. So you can see that this graph has produced good results. It shows that it's good results. Next slide, please. So, from my research, I'll suggest that, or I'll see that a global network with low Earth orbit satellites is actually possible. Then, and African nations can put in a joint effort for low Earth orbit satellites mobile networks. And I recommend that the ITU, that the group looks into this and makes regulations on it. Next slide, please. So yes, my project was supported by All Nations University and the All Nations University Space Systems Technology Laboratory. Thank you.
Thank you very much. Journalists. Any questions of journalists? Going 3, going 2, and going 1. Please, one more time, one question. So you have anything here, but it says you are set free. All right. Next is Eric Akobi Abam. Eric Akobi Abam. Eric, please round of applause for Eric as it comes. Eric, you are my height mate, so I'm bringing it down for you. Our height senior guest left. This one is going to be a sharp change because we've been talking about space. Now we're coming to apply the data from space to do analysis from Earth here. So my project was based on assessment of land modification dynamics
in order for us to achieve land degradation neutrality. Land degradation neutrality simply means land in balance. Next slide. So these are the outline. Next slide. Okay, making it brief, you see, there have been a definition of the sustainable goals, but there's only one thing that links all of them, if not or almost all, that's land. Land becomes the connectivity between all the sustainable goals. So therefore, when we are able to protect and harness land, we'll be able to achieve most of the sustainable land. So therefore, the reason for this research. Next slide. But one thing we found out is that anytime we do land modification analysis, most of the researchers use only a single parameter, whether we use land cover or soil, but in my research, I tend to follow up on the land degradation neutrality model and combine these three important parameters to assess a very important basin within Ghana. That is the Plains Basin. The Daisy Basin is of much importance because it supplies water to the Accra, southern part of Accra, and it also houses one of the important ecosystems, that is the Atiwa Forest. So it's much important to Ghana and the whole world. And also houses, there's a lot of mining activities and illegal mining activities going on. So therefore, there's a need for assessment and then making the progress to restore to achieve the neutrality land impact. Next slide. So this is my approach. In the approach, we use machine learning. Everything was done within Google Earth Engine and then Brain.x. We computed for land use, land cover for these epoch years from 1986. So the baseline for the land use, land cover in the middle of 2015 and 2018 and then 2020 using random forest algorithm, because that will help us to be able to have a very nice classification within the various classes so that we can input that into the Brain.x. And then the next part was the productivity aspect, because the parameters used here were the land productivity, soil carbon, and then vegetation. So to derive the productivity from the land, we use normally different vegetation index, which was derived from the satellite data, which was computed using the random forest algorithm to do the classification. Also, the productivity, we use the Markendo productivity to analyze the changes, to detect the changes, to characterize the hotspot of degradation. And then last, we used the soil organic carbon, was computed from the soil grid. And then all these combined were projected into 250 meter resolution, and then feed into the land Brain.x so that the characterization of the hotspots of degradation will be assessed. Next slide. So these are the results that we find. Within the years, we saw that the southern part of the basin were very degraded due to the expansion in infrastructure and development, and then the southern part, which falls within the eastern region, were also declining in vegetation. Therefore, you can see the impact of illegal mining within those places whilst there's infrastructure development in the south. And then the study also saw a negative change trend in all of the parameters that we use, the land cover and the soil, and then productivity, a negative trend. Now, next slide. Now, when there's, these are the changes, that percentage changes that we detected when the analysis was done. We saw that if settlement average we label as artificial land, including all the other land factors except vegetation, water, and grassland, were increasing throughout the year. They have increasing trend, and then farming also, agriculture also have increasing trend, whilst forest and other vegetation were having decreasing trends. As you see, there's a pressure on the basin on land. And next slide, please. And then we look at the hotspot, we characterize the hotspot, we define them into 5 categories or status, where we look at the decline, totally decline areas are in the red patches, and the moderate decline, the stress, the stable and improved. And then we look at the status, is it stable or is it degraded or improved or no, the red exposure. Yeah. So in all this, we when you combine the three parameters, if there's one lacking, it means that place is degraded. If all of them are in a positive increase, that means that there's an improvement. Next. Okay. After all this, what is the impact of the degradation? The impact of erosion, the impact of land changes in the land architecture, it causes erosion, sediment movement. So we want to see which part of the basin contributes most of these sediments. So we use the SDR, the sediment delivery ratio, to analyze to see which part of the basin is able to produce more of these sediment and where do they carry them to. Okay, so we found out that there was about 1.5 kilometer tons of every year soil that are being reloaded every year from these four spots. The red part is the most places where there's higher sediment delivery. Yeah, even though there was getting to the northern part of the basin, there was a minimal soil delivery because there was some. That's where the forest zone of the basin is. Yeah. So the implication is that if you want to do a restoration, that means that you have to focus on where most of the sediments are coming from, and these are materials areas. Next slide. This is also the percentage run within the areas. If we categorize the bases into sub-basins, sub-areas, and land units to see so that we can inform implementation of sustainable land management. Next slide. Okay, this is also the explanation of after computation of the statistical analysis behind it, we found out that 80% of the basin contribute to sediment delivery. That means that informs why Accra have a problem of flooding each year when there's a rainfall, because the sediment coming from the up basin is much enough to fill up these gutters and the rest. Yes. So in conclusion, our study found out that combining these three parameters, such as the soil organic carbon, the land use, land cover, and also land productivity, we are able to make real assessment of the basin so that we inform and to know where particularly we can make this sustainable change, not just to do activities anywhere, because these things are very expensive. And secondly, it also informed, we also find out that using random forest algorithm or machine learning is able to give us high accuracy when we are classifying the land into different classes. Therefore, it is always, and also applying these things in Google Earth Engine give us the room to apply these algorithms so that we'll be able to find changes within the land modification. Thank you.
This one did exactly 8 minutes. So I don't think we can ask questions. Okay, I'll give the floor to I saw your hand up first, and then okay, so let's go here first.
Thank you for a nice presentation. I will not ask a question, but a suggestion for you. I think your presentation were nice, but I was lost in the process.
Presentation, I saw the flowchart. You were mentioning algorithm, but I couldn't see any algorithm backing the flowchart presented in your presentation. So I will advise us the subsequent. Is it a final project area or you are ongoing?
Okay, I made a selective maps to put here. I have everything, even in the computation within the Google Earth Engine, how we go about it and everything, the graphs and everything, the complex.
The reason behind my question is that it's a confined area. You can have people who don't have any background about what you are saying, algorithm. So I would advise that next time you try to bring in some of the algorithms within the presentation so that those of them don't have any idea about the algorithm behind it. Know more about algorithm.
Thank you very much.
All right, thank you very much. This is one more round. That's how I said what is happening. They are trained as street bullets to me who don't know anything about this. Okay. Goku here. That's you. Listen, just pa. That's your surname. Please mention your name for us.
Good evening. My name is Goodman Jasper. So I know definitely most of you will not be able to mention it.
I saw the thing is, I was wondering which one I should
So this evening I'm just going to do some deep space thing. As we are talking about the Earth, I want to go into deep space. And that is, we are looking at the exoplanet. The exoplanet simply means planets that exist and they are outside our solar system. We know they exist, but they are outside our solar system. The 8 planets that we know now. So these planets also exist and they are outside the solar system. So that is what we are looking at. So I'm using the Kata 1b. The star that it is orbiting is Kata 1, and then the planet is Kata 1b. So just look at us as Earth, we are orbiting the sun. If you are to name the Earth as an exoplanet, it's going to be Sun 1, and then the first planet that is orbiting the sun is Mercury. So Earth will be Sun 1, and then the Earth will be Sun 1b. It means we are the third planet or the fourth planet, whatever. So we are looking at the case of Kata 1, and this is a NASA program. And why are they doing it? They want it in such a way that in future they don't waste telescope time, like the James Webb telescope, and then they always waste telescope. So they are looking at ways and means to make sure that when they want to observe this exoplanet, they observe it with precision. The time that it is going to transition within each star, they will be able to capture the exact time and not waste the telescope time. So next slide, please. So I'm going to walk us through this, the method that are being used to detect this object, and then the other points. Next, please. So as I said, these are exoplanets, and currently about 6,000 of them have been discovered out of the million that we believe they exist. And the discovery still go on. You can also do one. You can also detect one. You can also discover one, and it will be named accordingly. Next slide, please. So basically, 5 methods are being used, but the predominant one is the transit one. And you can see the number of exoplanets that have been detected by the various methods. So I'm going to be talking about the transit method, which have been used to detect the Kata 1b. Next slide. So this is how the transit method looks like. Just imagine put yourself in a room, then you put a lamp on a table and you begin to move around the lamp, and then when you just look at yourself in a wall, one side of the wall. Anytime you pass at that side, you see that you cast a shadow on the wall, meaning you are blocking the light that is coming from the lamp to the wall. So that is kind of like the transit method. Next slide, please. So the Kata 1 was detected using that method. And because it was detected by the Kata Foundation, they named it according to their foundation. So Kata 1b is the first exoplanet that is orbiting the star Kata 1. Next slide. So this is a simulation of about 3 objects orbiting their star, and then that will give you how they look like. So if it is just one, you get the one. If the number of stars that will be orbiting that, the number of exoplanets that will be orbiting that star, you will get the multiple just like the way you are seeing it. Next slide, please. So what is the main aim? As I mentioned, the main or the global aim is to make sure that we don't waste telescope time. But in Ghana, we are looking at it that we must also have our students contribute to that major aid. And so we want to train Ghanaians on how to use various robotic telescopes. This one is not about using it. You do the schedule yourself. You don't have the telescope, there's no problem. And we will train you how to use the robotic telescope. You do the observation, download the data, and then you perform the photometry that we need. Then you report it to the international body, which is the American Association of Variable Star Observers, and then they will take it from wherever you are. You can also do it as a research that you do your publication if you wish. Next slide. So, what are the requirements? It's simple. Get a computer. All software are online. You don't need to install anything. Good internet connection. If you are in a village that the internet connectivity is very difficult, you always do it in the night time, like myself. I mostly don't sleep in the night. Get a Gmail, because most of the data you have to upload it in your Gmail, Google Drive rather, and then you use it from there. Then if you have the passion for astronomy, space science, or any of the related, you can join the group. So this is the exotic software. It has 3 ways of doing the photometry. We have the basic, which is the beginner. We have the standard, and we have the advanced. All of them function the same way, but they have different approaches. The basic means you are just a first comer, and so you need something that will boost your morale to continue. So you get a certificate from there. But if you are using the advanced, it means you don't need a certificate. You just go straight to business. Let's go next slide. So how do we get the data? 2 ways to get the data. Good. You go to the next slide. 2 ways to get the data. The first one is you look at the various exoplanets that are within. So you can get all the exoplanets that are up in space, that are ready to be observed. In that month that you are here in September, all the exoplanets that are available that can be observed in September can be seen in the micro observatory database. Then you schedule it there. If you think you want to do a planet and that planet is not there, then you can go into their database. Someone has already done that probably some months ago. You can also go in there and then you download the data. Then this is the telescope that is doing that. You capture the data if you schedule it yourself. At least 24 hours, you get your data and then you continue. Next slide. So this is the exotic data, 4 steps in the advanced. So I'm using the advanced one here. 4 steps. The first one is you mount the Google Drive. It means you have to download the data and load it in your Google Drive. And then when you go into the exotic software, you then mount the exotic on your Google Drive, load the various libraries that are needed. This one, you don't write the code yourself. It's just about clicking, and then the software will do that itself. By following the various parameters, the software will be asking you to do it. From there, you then give the...
Right, your time is up. It's wrap up now.
Thank you. So you then do the other information that are needed. So those that will be interested, I'm available to do that. Then this is the chart that you then use to identify the particular planet that you want. Then you do the various data entry, and then you get the rest needed information. So this, you can see the dip there in the red line. If you look at that image, you see that the transit time was not really captured at the way we want. You can see a baseline at the right and left, but there's a dip. That is what NASA don't want. So they want that dip portion alone. So they want in the future, they just capture that dip portion alone. So now we want to get rid of those lines.
All right.
So these are a lot of them. I've done about more than 10 of them to them, and I still continue to do those. Thank you. I have other programs that we run in the same distance. Thank you.
Thank you very much. Please, one of those for you. Yes, any questions for us? Anybody? All right. Anyone? Okay.
Thank you. It's a comment, and I don't know whether Olaf just asked. Are the data that is received from these sites, are they models of correction? Are they modified before you extract them, or you have to get it before you work on the modification?
Okay, so this is an observation that you have done yourself. No one has done it for you, so there's no modification in that. You observe the thing yourself, download that data yourself. So it doesn't go through any modification. You will download it and then do the graph that you will see. So there's no modification by any other person other than you and then the telescope.
I want to get it. We have some instruments. We make good data. They do some calibration of correction before they are displayed on the dashboard. Others give you raw data stored in the memory. You have to take it out, then extract that data. And I want to find out, with your telescope and what you are doing, is there a similar activity that the system where you're going to take your data for does some correction? I don't know which term you may use, or it just presents a raw fact that you are now going to work.
Yeah, so the telescope will capture the object that is transiting and then store it in the archive. So you go and download the raw data. There's no modification in it. You download the raw data and then you use the logic software to do the thing yourself.
Okay, so you made mention of the transiting method. My name is Yaya. You made mention of the transit method. How sure am I that what I'm witnessing is as a result of Kata 1B and not some other bodies that's messing with what I'm witnessing?
Okay, so when you go into to study the observation, the various exoplanets will show up. So you see that, let's say today is 7th, right? So if you go into do the observation, if there's an exoplanet that is up in the sky for observation, you see the name. If it is Kata 1 will show. If it is Kata 1 is the star, but Kata 1b is the exoplanet. So Kata 1b will show. If today Kata 1b is not showing today, but is probably up in night, it will still show because we are looking at the whole month. So the whole month, all the planets that will be available for observation will show up in the database for you to see that this is the day that this particular exoplanet will be up for observation. You can schedule it in advance, so you just go and click on that date and schedule it. When that day arrives, the telescope will capture the images of that exoplanet. Even though the day has not arrived, you can schedule it in advance, meaning you are saying on this day, capture this exoplanet images for me to do the photometry. I hope I've answered your question.
All right. Thank you very much. Please round of applause for Justin. Next is Evaristus Uzochukwu Lydia. Next, Divine is not here. Okay. Then so we have Angela Chu. Angela. Is he assistant or who is the assistant? So there are two of you. Angela and you. Middle. We are also physically out. Wait for the money. Okay, Angela and Leon, please round of applause for them.
Good evening. As Bradley mentioned, my name is Angela Chudabrasi from All Nations University, Incorporated. So I want to take you on a journey on my project titled Space Education for Underserved Communities. Next slide, please. All right. So the vision of this project is to deliver a first-time exposure to space technology to everyone. Everyone is involved. We are taking space education to everyone. Next slide. The missions of this project is to demystify space to all, inclusivity in space education, diversity in space education. So our target groups for this project is the streets, marketplaces, orphanage homes, prisons, and the others. So we want to reach 100 communities with this project, and we've reached so far 10 amazing communities, and it will surprise you the kind of communities you'll be able to reach with this project. Next slide. Okay, so this community we reached is the marketplace, where we took space education to the marketplace. So here we use the VR technology, that's a virtual reality. So the virtual reality is a technology that gives you the experience like you are there. So with this, that we went to the marketplace, the market women had the opportunity to experience aircraft cabin with the virtual reality. Next slide. We also went to the School of the Deaf in Koforidua, where the students had opportunity to experience the solar system and drone piloting. So you can see the smiles on their faces. This was the first time they were exposed to something like this, and it was really amazing, even for us that were there. Next slide. We also reached out to fishermen and fishmongers. They also had the opportunity to tour the solar system as well, and the drone piloting as well. So we reached the fishermen, the fishmongers. This slide. So this is yes. So we reached out to some of the fishmongers around the community, where they were able to experience the solar system. It was amazing. This was their first time, and it was very nice to reach out to them in that way, using the virtual reality. Okay, so we also reached out to the Koforidua prisons as well. Then we couldn't take videos because it wasn't allowed there, but we had the opportunity to take STEM education to the prisons. I mean, you know how they are criticized in our communities. So when we went there, they were surprised that we came and they brought STEM to them. It was their first time experiencing something like this, and we were pleased. Next slide. Okay, so my other colleague, Mabel, will take you through this project. Thank you.
Thank you very much. So, as you rightly said, I'm Mabel Mafo, and to conclude this session, I'd like us to take or share with you an innovative initiative that we are embarking on, that is the Street to Space project. So one might be wondering how somebody on the street can be taken to space just like that. So this initiative is a project that is to help African child on the street. There are some children that are on the street walking just to cater for their basic needs. So we went for a STEM outreach, and then we met a young girl on the street walking during school hours. So we got to her. So that is Deborah. And Deborah is our model for this project. We met her during school hours, and then we went to her, asked her why she's not in school, and she made us know that poverty. So due to that, she was walking on the street just to cater for her basic needs. So in view of this, we are taking her to the classroom so that she can get to experience what space science is about. So that is Deborah on the street, walking during class hours. So he joined me through the success story of Deborah. Now Deborah is now back to school and she's now in the classroom as I see in the video. Okay, so the Ghana Space Technology shouldn't be just about research, shouldn't be just our laboratories. It can also help build children a brighter future to also get to know about what space science is about. Because we introduced her to the VR technology and then we got to know that she was so amazed and the interest for space science was there. So we used this initiative to help her build her career and also develop her love for space science. And I think we can be, or Africa can also bring up a female astronaut, right? Is that possible?
Oh, it's possible.
So that we can be the first African country to raise a female astronaut from the streets. Because yes, she was on the streets, now she's experiencing STEM, most importantly space science technology. Right, so I know most people have been touched by the story of Deborah, and as you can already see on the screen, we are now providing for her school needs and all of that, just to make space science technology a better place for all African children battling poverty and all that. So in case you are touched by the story of Deborah and would like to share or help cater for your basic needs, you can help with a term fee, second term fee, books, uniforms and all that, so that we can help the dream of Deborah to come to pass. Please, I hope we are going to share or help Deborah in space science technology. Please, are you going to do that? Are we supporting this journey? Okay. So right after here, if you've been touched by the story, can you see me so that we can share the success story together and bring out the first female astronauts in Africa? Thank you.
Thank you very much. Unfortunately, I didn't see it to be, so I'm standing in for a minute. We'll take 2 questions. Any questions? One over here.
Thank you very much. I think I'm very impressed about your presentation, and I think you made my day. Actually, how can I join? I want to be part of the team, so if I can join, I'll be grateful for contributing. Thank you.
So should we speak to you afterwards to join? Is it possible or?
Sure, so right after here, can you see us and then we can be part of the success story.
One more question here.
I'd like if you share, I would be glad if you could share any difficulties that you faced when you started. And it looks like it's a whole team thing. If you could share any difficulties you faced, and also be willing to volunteer those efforts.
I think one of the difficulties we face during this thing, or something that we are facing, is, you see, some people are not oriented on the space. Some people do not know about it, so it's a new thing to them. So you sometimes need to convince them so that they can get in touch with it. So that's one of the difficulties that we face, and by the grace of God, we are trying our best to make sure that space is taken to the streets.
Any more questions? One last question.
Very nice presentation, but I want us to go back to the topic, the main topic. Yeah. That's the topic.
Yes, space education for underserved communities.
Your target group were?
Our target groups were the marketplaces, orphanage homes, prisons, fishermen,
and the streets.
Yes,
so
and the
what made
streets.
your selection of the streets? That's your main thing, because in the video I only saw just to hit you, and the other target group were not involved. So what made you select only the street?
So, as we started from the beginning, we are taking STEM to unusual communities. And we said we've already taken it to 10 communities. And that is what we presented on. There are more 90 communities to visit. So all these places can be those people that know nothing about STEM, space science education. So we are still reaching out to them. So there are no any categorized place where we are taking it to. The overall theme is to unusual and undeserved communities. So if you don't know about STEM or space science, we bring it to your doorstep. That's what the initiative is. Okay.
We have a short time for the presentation, so I think we have to.
Thank you.
Please make some noise for this. Next up, we have Isaac Mensa. Is Isaac Mensa here? Please take stage.
I believe that.
Good evening. My name is Isaac. So, monitoring what I'm saying in real time. So, for the purpose of time, I will quickly talk to you about the problem, and then you can move to the resource aspect, and then I will talk to the resource. So, when we talk about Galamsey, I think what comes into mind is the negative impacts that causes, but there are other positive impacts of Galamsey as well. So the sector employs about 49.5 million people globally, and then about 1.2 million Ghanaians also depend on the sector directly. But one of the major problems about Galamsey is it's not being monitored in near real time for maybe timely intervention. So what we are currently doing is we want to monitor this event from space. And then we are using another satellite images, synthetic aperture radar. So Albert and Dr. Beatrice talked about optical images. This has a problem when you are monitoring in Ghana because of cloud cover. But the synthetic aperture radar has the capability to penetrate through clouds, so you can do near real time monitoring. So what we are doing is we are leveraging AI technology and processing technologies to try to monitor this process in near real time. So the approach, so you can move to the later session. So the approach we are using is we have time series images of Sentinel-1. Then we try to analyze the backscatter values over time. So when we have deviations in the mean and then the standard deviation, Galamsey activities usually causes a drop in those activities. So we can use the mean and the standard deviation drops to get an alert of any forest disturbances happening. So once we get that, we also use some deep learning model, the UNet model, to try to do a secondary classification to infer what type of disturbances is that. So you can have other drivers of forest disturbances like farming and other things, so we have to actually do a further analysis to know what type of change that causes the alert. So this is the change detection method, the equations behind the change detection. And then you can move to the next slide. Then the next slide has information about the AI, the deep learning model we implemented. And then you can move to the next slide. So we tested this approach in Ghana. We use high resolution images from Telescope for our validation. We also use optical Sentinel-2 data. And then we also got some yearly footprint data from SEGIS as part of our validation. So you can move to the study areas. So we tested this in Ajuman-Porian district in Ghana, a forest reserve in Ajuman-Porian district. And then we also tested it in the Wassa-Kupon area. So this is the change detection method. So we can see we are able to detect, get an alert as when the activity starts. So we are able to detect this thing in near real time. So there is high intervention activities that you can do. So once we detect the activity in the area using Sentinel-1 images, which has the capability to detect in real time. So once we have the detection, we want to also further discriminate, or we want to differentiate any potential activity that might not be galamsey. So we want on further to try to also implement a secondary classification method which will try to differentiate galamsey from other activities. So you can see we can do the change detection, which will tell us when the change started, and then we do another analysis to know which one. So you can see from the screen, there is a site in Ajuma Korean which has a lot of disturbances going on. So you can have farming activities, galamsey, urban expansion, and others like that. And then once we get the alert, we are able to differentiate what type of alert is that. So we tested this against other methods that has also been implemented in Ghana, that has been reported in literature. So we tested our work against it, and you can see we are having F1 score of around 91%, which is going to try to say it's able to detect accurately over 90% in Ghana in the study areas we tested. And then one of the major problems when you are using that observation data from real-time monitoring in Ghana has to do with the high intensity rainfall we have in Ghana. So we try to test the approach during both the wet and then the dry seasons. So we can record an accuracy which has less commission errors of 7% during the dry seasons, and then even during the wet seasons where we have a lot of issues, we are able to record 90% accuracy. So you can move to the next slide. So we try to see how fast can we detect the activity. So we are talking about detecting galamsey in real time. So how fast can we detect it as soon as it starts? So we tested it in Wasatropon area because we don't have a lot of validation data. We try to test it outside the rainy season, so we use the dry season data. So we have 2 galamsey sites which is happening close to buildings or close to settlement area. So you can see we are able to detect the first one in 6 days after it starts, and then the other one we are able to detect it in 9 days. And then we try to also assess whether those activities are really galamsey by the secondary classification, and then we are able to see that differentiate galamsey from other disturbances as early as possible, and then the lag time can be up to 18 days. So this is going to say that we have a method that can detect the activities and as early as possible once they start cutting down the trees. And then this can be as fast as possible, and then the delay is up to 18 days. And then, so we currently, in Ghana, I think we rely on on-site visits to try to close down the activities. So we did this method, this work, maybe trying to support this on-site activities, so they wouldn't have to maybe go to remote areas where the activities might not be galamsey. So we are actually open to collaboration on how we can use this thing for elevation monitoring. So we can actually try to reduce the cost of maybe using high resolution images that Albert was talking about, because this is a cost effective method. The Sentinel-1 data we use is freely available, and then you can get this data every 6 days. So we can develop this further into a website or a dashboard where we have this dashboard updated every 6 days as and when the activities is happening, and then where the distribution is heading towards across the country. So these are some related publications that we have published related to this kind of work. And then this work, you can go to the next slide. So this work is supported by the Research Aroland and then Melite University in Aroland. So thank you for your time.
Thank you.
Do we have any questions? Testing. Questions? No questions? Thank you, Isaac. Next up is Jennifer Darko. Jennifer Darko. Please welcome her to stage.
Good evening. So I'm going to speak a bit about the research I did during my master's degree and how I think it can be applied to sustainable development in Ghana and beyond. So just to explain that first slide, a phase A feasibility study is a conceptual design level analysis of whether a mission could actually be possible. And that's within a given time frame, budget, and technological availability. So the next slide is an overview of what I'm going to speak about. Maybe it's a bit compressed now that it's 8 minutes, but the main thing is the application, so how the model I use can be applied to Ghanaian user needs and maybe be expanded to a potential mission in Ghana. So a bit about me. I spoke about this to a few people. Next slide, please. I spoke to a few people about this, but I'm 3/4 Ghanaian and 1/4 British. I started my schooling here in Accra, and initially my teachers thought I was going to be an author. But then I always had an interest in maths, science, and geography in a quieter way that they didn't really identify at the time. But I was 8 when I went to the UK to continue my education, and then went on to do an undergraduate degree in aeronautical engineering and a postgraduate degree in space technology. So I'm hoping to specialise as a researcher in the field of thermal and mechanical design of spacecraft. And I've been trying to learn more about the African Space Agency through a course with the African Space Leadership Institute, which I recommend to everybody. And I completed several articles on space policy and development in Africa, so that's where I'm focusing to try and learn at the moment. So my actual project, which is on the next slide, it was initially supposed to be about space weather effect on a potential Mars base on the surface of Mars. But this was adapted slightly to align with my supervisor's existing research. So you can see the project objectives here. And the idea is to use the principles from space mission analysis and design to create a model to establish whether this mission would actually be feasible. So this was to put an observatory at the second Lagrange point of Mars, which you can see on the diagram on the right side next to the words Mars orbit on the Sun-Mars line. So this orbit was chosen as a unique perspective because Lagrange points offer stable or semi-stable orbits, reducing the amount of propellant that would be required to maintain the satellite there. So this is kind of lowering the cost of the mission. So my research was actually looking at the environment around Mars and then enabling me to choose a suitable instrument suite for this mission from heritage instruments. So I completed this design at a system level, but I think it could be expanded to a subsystem level to deliver mass, cost, and power purpose. Next slide, please. So why are we interested in Mars? You might be wondering, isn't the focus on Earth at the moment? But Mars is our most geological similar neighbor. It's a pristine rocky body, and it's currently preserved as a kind of planetary laboratory. So no one has actually landed organic matter on Mars intentionally. So it can be used to help us understand the origins of the solar system and the universe in general through robotic exploration. So these were the 3 phenomena that I identified through my research as having the main effect on the Martian surface and the Martian system. So my mission objectives were focused on establishing what effects these 3 phenomena actually have on Mars. And then this informed the instrument choice and the later design of the spacecraft. Next. So I thought that this was really interesting because these images were taken from the Mars Express mission, which had what was not originally a scientific instrument aboard. It was actually kind of like a webcam, so it had basically a 2001 level webcam on a spacecraft, which was then used for outreach images. So you can't say that we don't have this technology in Ghana already. If they put this on a spacecraft and launched it that long ago, we can make these contributions right now, which could help us understand things that weren't even intended within the mission. So basically the idea, in kind of summary of this mission, was to see a global image of Mars and try and establish what actually happened to it. Because if you didn't know, Mars used to have what was expected to be an ocean. And so people were trying to understand what happened to the atmosphere and the ocean of Mars, and if this could potentially be happening to Earth. And understanding this could help us see and understand climate change and see what the actual risks are long-term to Earth. Next. So the scientific conclusion of my research was that it is possible to complete the mission that I suggested to the second Lagrange point with the chosen instrument suite within a medium-class mission framework. And that would facilitate the analysis of the phenomenon that I mentioned and contribute to that global image of Mars that we receive. The relevance here is that I think through knowledge sharing and collaboration, Ghana is already ready to start contributing to these missions as they're happening. There are a lot of plans in Europe and the US to send missions in quick succession, and we have the technology, we have the skills, and we have the curiosity in Ghana to actually start contributing to these missions now. And in terms of specializing the model to Ghanaian and African user needs, we want to preserve our resources and see how we can actually apply what we have here to make our own contributions in the future, rather than repeating the work that's already been done. So I'm here because I think this is where the potential is, and I'd like to contribute in terms of research. If anyone's interested in collaborating, my LinkedIn is on the next page, and if you have any questions for me, please take them.
Thank you, Jennifer. Do you have any questions about Mara's presentation? Well, back here.
Thank you very much. I think you had a nice presentation. I wouldn't ask a question, okay, but I will suggest for you that most of the presentation is slides. I think you have to throw a bit of light on the space phenomenon, because I saw one of the slides showing some space phenomenon. I think having a suggestion, explanations on that will make the work more clear, more nicer, okay? Yes. And your specifics are supposed to be clear. Okay, your specifics are supposed to be clear. Specifics.
Yes.
Your objective. That's what I mean.
I have the slide with the objectives.
Okay.
Is that what you meant?
Okay, I was thank you very much.
Yeah, I think if I have some time, I'd like to explain the plasma physics behind it.
And I think I'll succeed with you. Okay? Okay, thank you.
Thank you. Any other questions? Going once, going twice? Thank you, Jennifer. Next up, we have Chidibert Christopher. Chidibert Christopher. Nope. Then we have Godfred Chukwumeka Ayama. Godfred and his team. All right. Greetings, everyone. I hope you're all doing well, enjoying the conference. Yeah. So, the Ghana Space Society is what I'm going to talk about. So, I'll be talking about my ongoing efforts and some proposals we have. Next slide, please.
So everyone must have a feel of space. Don't you think so? Oh, don't you think so? Yeah. So this is a school of the deaf. So we visited this place. I think my colleague spoke about that earlier. And we were able to engage some of the adults there with space science and some educational facilities. And when we were about to leave, the little girl in the picture, she didn't want us to leave without experiencing something also. Yeah, so we allowed her to, and she was really amazed. Next slide, please. Yeah, so one of the challenges we have is a very large number of people who are very interested in space science education here in Ghana. So we have been able to reach over 15,000 students, yes, with space science education. So some of the skills our students learn from the project include satellites, developing satellite antennas. So you can see how the students learn, and they are able to build their own satellite antenna. And in the next slide, I will talk about a few of the schools. So this project has reached a number of schools, not only in Ghana, so we have some other African countries who have been able to reach about 18 other African countries here in Angola. We also reached Nigeria. Yes. All right, next slide, please. Yeah. So the students also learn how to track satellites after building their satellite antennas. So they are able to receive signals from satellites in space and able to understand after taking the classes. Yes, so we are impacting lives. Okay, so I'll hand over to my colleague to continue.
Thank you, Godfrey. So my name is Jehel Asieto-Sla, and I'm going to talk about an ongoing project at All Nations University. So the name of this project is the All Nations University Space Van Project. Okay, so at All Nations University, we have over 200 experiments in our space science technology laboratory. And we're privileged to have students from various schools all over Ghana to come and have an experience of these experiments. So this initiative, we want to take our experiments from our school grounds to the schools. Yes. In doing this, we'll be able to reach the large number of students Godfrey mentioned earlier, and we'll be able to solve the problem of unavailability of practical space science laboratories or equipment in various schools in Ghana. And we'll be able to also open the knowledge of space science to students all over Ghana. Yes, so some of the experiments we have include the light intensity control system, the sound intensity control system, the telescope. We also have various experiments and apparatus to conduct physics, chemistry, biology, and mathematics experiments. Yes, so now I want to add that we are applying for funds. Thank you. We are applying for funds to get our space van. Yes, and want to entreat you, if you know where we can get this, we can get the funds, please let us know. Yes. So we can. So my sister will continue with it. Okay, so I am Peniel Toxler. I'm here to talk to you about one of the projects we are working on, which is incorporating gaming into space education. So our aim is to break the theoretical regime Hence our proposal to GPS, which is to incorporate space education games in schools in Ghana in ICT training programs to complement the traditional space education at a lower cost. So we know that space education, for it to be practical, it requires a lot of funds. However, with the games, there are already games in place, and we would like to implement that. And we are proposing to GES to incorporate that into ICT training to give each student a practical feel of what they are studying, and that leaves a mark in them, and then that's more memorable. So one of the games is Space Engine. So up there on the poster is some of logos of some games. So I'll talk about the Space Engine. Space Engine has a feature of simulation. It gives the user the opportunity to pilot spacecraft and also explore the universe. And these games make it possible to practicalize everything that the students are learning, and for them to be able to retain more, and then to retain their motivation to study space science. Thank you very much for listening.
Do we have any questions for the All Nations University team that has made a presentation? No? We have one question.
Thank you very much. My name is Ebenezer. I'm an aerospace engineering student from KNIST. So I like the fact that you guys are reaching out to other people elsewhere so that they can get a feel of the space. But then my question is there any online course for the creation of antennas and other things for other people to also reach out to you guys? Thank you.
Okay, so we actually have a YouTube channel, and we have some videos out there, which is actually a full course to study in relation to satellite. Go ahead and talk more about it.
Right. So about the YouTube channel, so if you go online and you search the All Nations University Space Systems Technology Lab, ANU SSTL for short, and you see a link to our website. So from there you can see direction on how to register. On YouTube also you can check for a channel, the African Space Station Project, which was presented yesterday. So if you want to check out our videos.
We have another question back here. All right, another question. If you go on Google right now and you type African Space Station Project, this video, this project, the online project will pop up. Thank you, Ernest. Do we have any other questions?
Thank you very much. That's really, really very impressive. And I was really impressed with the way in which you wanted to make sure that young children and even deaf children were included. And I just wanted to know how you communicated when you went to the school for the children who were deaf. What did you do with them? How did you actually communicate with them? How did you share the excitement of space with deaf children?
Alright, so we were able to contact one of the sign language instructors. Sorry, someone who understood sign language, because they already taught them sign language. So that's how we're able to communicate. So she will translate to them what we are saying and also to us so that we understand. Thank you.
Thank you very much. I don't think there are any more questions. Please give me a round of applause.